Looks like we're live. Hello everyone and welcome to yet another Azuzin session. Hello, welcome. Let's make a little bit of an announcement and officially start the stream. How about that? So, the usual red circle live on Twitch. And what are we doing today on Twitch at television website? Today we're doing neural networks with Raylib visualization, right? That's what we're doing today. I'm gonna give the link to twitch.tv, https twitch, oh my god, can't type today, twitch.tv/Todin. And also I'm gonna ping everyone who's interested in being pinged, and there we go. The stream has officially started. So what are we doing today? Essentially today we continue developing nn.h, which is a simple STB style header-only library for neural networks. We've been developing it for quite some time. I really enjoy developing it because I'm learning a lot of interesting things. I'm gonna give the link to this thing here in the chat, and for people who's watching that on YouTube, it's gonna be here in the description. Right, so what we were doing on the previous stream. On the previous stream we were trying to implement like a very simple visualization of how the neural network learns. Essentially, we would visualize the neurons and the connections and color them differently depending on their strength, right? So let's actually take a look at how it looks like. Right, so what we implemented a simple adder as a neural network. So I don't remember how big it is. So it can actually add only 4-bit, two 4-bit numbers. That's what it can do. Right, and essentially while it was learning to do that, we were taking snapshots of the state of the neural network, right? So if we take a look at one single snapshot, so I think we can start at 0, 0, 0, and let me actually make a black background. So this is how the neural network initially looked like, right? It has 8 sort of inputs, right? So 2 hidden layers and actually 2 outputs. Right, so this is how it looks like. And essentially what we can do now, we can try to display all of the images and just go through these snapshots of the neural network and how it learns. So here we have 50 snapshots, and I think it doesn't really have like do anything until like snapshot 13 or something like 4. Yeah, so on 15th snapshot it sort of jumps and learns really quickly and basically continues learning from then, and sort of as you can see it keeps adjusting the things. Right, so here I'm going backwards, right? So this is the sort of initial state, and then I go forwards, and this is how it's sort of adjusting its weights and biases until it learns how to add 4-bit integers. So that's pretty cool visualization. It's actually kind of cool to see how, right, it just jumps to a particular configuration and then continues like adjusting weights and biases. So that's actually pretty cool. And this is not particularly a convenient way of looking at the visualization, if you know what I mean, right? So what I initially wanted to do, I wanted this thing to be actually like a GUI style thing. So essentially I would start the application, it would open a window and show me the process in real time. It will show me how this thing learns in real time, right? So, and this is what I wanted to essentially dedicate today's stream for, actually, I'm sorry, I don't speak English. Right, and to do that, we'll need to use some sort of a graphical library. And I was thinking, what kind of library do I want to use? Initially, I wanted to use SDL, but SDL is kind of an ass when it comes to like shapes that are more complex than a rectangle. So if you want to draw anything that is more complex than rectangle, you just use SDL as a glorified OpenGL initializer, right? So, and what I decided to do today, I decided to give Raylib another try. I already used Raylib some time ago, just like checked it out on the stream, but didn't really do anything useful for myself in this library. So I decided to give it another try and see how we can utilize it for visualization of the neural network learning process, right, if you know what I mean. So I'm going to give the link to this library in here, right? So here you can find it, and also for people who's watching on YouTube, it's going to be in the description as well. So let's go, I suppose. Let's go. I think some people subscribed, so let me quickly acknowledge the subs. Let me quickly acknowledge the subs. So the big guy won. Thank you so much for tier 1 subscription. It was 4 days ago, but I mean the Twitch shows me that, so I might as well acknowledge that. Tverskaya, thank you so much for tier 1 subscription. Thank you, thank you, thank you. And Shai resubscribe with tier 1 with a message OI. Oi, indeed. Thank you so much for resubscription. Marcio Neto, thank you so much for tier 1 subscription. A great weekend to everyone. Thank you. A great weekend to you as well. So Fengchi, thank you so much for 47 months of tier 1 subscription. Holy shit. The OG of this channel with the message Raylib. And by the way, so I recently created another option to support me, so you can find more details by doing the donate command, but unfortunately for that option I don't have any notifications or any perks yet. Right, so I apologize if you donated through these options and I didn't acknowledge that. In the future I will set up something to be able to acknowledge this option as well. Right. So let's go ahead and take a look at this Raylib. As far as I know, I do not have Raylib installed on my system. So one of the things we'll probably have to do, build it from scratch. Luckily, it's a very simple library, so it should be relatively easy to do so. Right. So let's actually clone the source code and build it from scratch. So I wonder, maybe I already have the source code somewhere here. No, I don't. Okay. So do lib clone and let's clone it. This is not particularly what I wanted. I'm not really sure what the fuck was that. Git clone, it just like, yeah, it clones something weird. Yeah, there we go. So, and I like to do a shallow clone, right? So essentially we have like 6,000 commits in here. I don't want to like clone all of these 6,000 commits. Right, so I'm going to just do depth equal 1. So isn't it header only? No, it is not, unfortunately. Right, it has its own build system and stuff like that. Build.zig, is it written in Zig these days? Okay. And that's the whole thing, I suppose. Right. So that's kind of interesting. So how much Zig is there? Not that much actually. Right, so it's primarily C. But they're using Zig as a build system. Okay, fair enough. I mean, sure, why not? But does it have any other options? Yeah, it does have CMake, so we'll be able to probably build it with CMake. Okay, so let's actually go in here. And okay, so that's cool. Make dir build CMake, and let's build this entire thing. I probably want to install it locally, and to install this thing locally I probably need to set up the installation prefix, but I don't remember how to do that. CMake set prefix. So let me quickly actually just... So CMake install prefix. Okay, can I just do something like CMake install install prefix? Right, essentially it's a prefix for the path where all of the installation is going to happen, right? So, and we're gonna install it at home opt Raylib. Right, so these days I kind of like to install the things that I build from scratch, like for a local user, right, without using root or anything like that. So maybe it results with a lot of waste if you're using multiple users, I think, but I kind of like it, right? So the fact that you don't have to use any like root and don't have to worry about breaking something is actually kind of nice. Right, so I think it's kind of cool. So as far as I know, CMake actually caches all of that in a cache, right? So we can try to find the prefix, and here is the prefix. It actually set it up correctly, right? So let's go ahead and just build all of that with 3 threads. Even though I can do 5, I usually do 5 because I have 4 hyper threads on my machine. So I'm gonna use 3 because I'm streaming right now. So I don't want to, you know, spend all of the resources on building this entire thing. So how are you guys doing? How are you guys doing while we are building this Scheiße? I have 4 cores, so I do 5 threads lol. Yeah, so that's usually a recommendation, right? So it's a usual recommendation that to spawn n+1 threads, right? If you have like n cores or n hyper threads, like the most optimal thing is to do n+1, but I don't know the justification of that, you know, best practice, right? This is something that I heard, and this is something that I do as a reflex, right? So if anybody more knowledgeable than me can explain why it is like that, so feel free to tell me. I do to n because I want my course to work for their money. You should have 2 GB of RAM per thread as well. Oh, yeah, that's actually... Yeah, since I have 8 RAM, 8 GB of RAM, so that makes sense. Alright, so it looks like this entire thing built successfully, which is kind of cool. So I'll go ahead and install this entire thing. Yep. So, and it installed it in the local thingy majingy, right? So this is where it installed it. Let me go to Raylib, and it's actually very small. Even though it's not header only, it consists of 3 headers, a single static library, and a bunch of CMake scripts, and also package config scripts, which could be actually very useful in the future. So this is the entire library, actually. So yeah, that's pretty cool. I really like the simplicity of this library. Even though it's not as simple as STB, for instance, it's still very, very simple. So one of the things I want to do before I go and try to visualize this entire stuff, I want to try some sort of like a hello world for Raylib. Do I already have some stuff for Raylib? Yeah, we already tried Raylib some time ago, right? So in 2021, so 2 years ago, right? So already kind of familiar with this library, but I want to try to do this thing again, right? So I'm gonna remove it, Raylib prob, right? Because I forgot everything what I did with this library. So okay, so let's include std.h. I'm not sure how useful that is for specifically Raylib. And maybe let's take a look at some of the examples that are available within the Raylib itself, right? So if we go to software and Raylib, so there's some examples in here. So what kind of examples we have? So there's a lot of stuff in here. So I want to take a look at the core. Is there something like a basic, right? Basic window. Yeah, there we go. Let's actually start with a basic window. Okay, so you just have to include Raylib. So here's the entry point. So you initialize the window, right, to create this entire thing. You cap your FPS to 60 FPS, right? So because you're running on a console, of course, that's what you have to do. And my keyboard has that yet fucking again, mate. God damn it. All right, so we cap it to 60 FPS, and then we organize the event loop, right? While window is not closed yet, right? So we begin drawing. We clear the background, draw some text, and the drawing, and then once the window is closed, we close the window. Well, I mean, it's not really when it's closed, when it should close. I suppose like this entire thing contains like an event loop, right? It basically drains all of the events from the event queue, right? And one of the events that you can receive is probably like the user request to close the window, right? And only then you handle a request, and then you just return. So this is actually straightforward. Like everything that you want to do is expressed with a single function call, right? So this is kind of cool. One of the criticisms I heard for Raylib is its functions don't have any prefixes. And since it's like a C-only library, there's no namespaces in here like in C++ or anything like that. So their names kind of pollute your current namespace, right? So I think this is like the main criticism of this library that I heard. It just like basically says that's it. You can't have function in your entire application called init window, and it's a very generic like name that you may want to have or may not. I don't really know, like or something like begin drawing. Like you can't have that. Though maybe it's kind of remedied by the fact that they're using Pascal case, and Pascal case is very unusual for a C program. That's actually very interesting. I was thinking, why do they use a Pascal case? And this is something that they actually emphasize in their sort of like a marketing speech, if you know what I mean. So if you take a look at the And the header of this thing, Raylib include Raylib Pascal case. Yeah, there we go. So it's plain C code, but it uses Pascal case. Right. So which is kind of unusual, like a C library using Pascal case. And maybe that's literally the reason, because it wants to have like a very simple, very readable names, but having a prefix for namespace purposes actually ruins that. But you want to have some sort of a namespacing. So that's a very interesting idea. I never thought about that. Yeah. So using case as a way of namespacing your library. This is actually kind of cool. I never thought about it. Yeah. That makes sense, right? Because if you are a C programmer and you want to have a function, right? You want to have a function called begin drawing. You're probably not gonna case it like that. You're probably gonna case it like begin drawing. So that's how you sort of like namespace that. That's very interesting. That's something to think about, so to speak. That is something to think about. So we'll get more subs. Thank you so much, MFamilyBG, for tier 1 subscription. Thank you. Xiaons, thank you so much for Twitch Prime, and Rebi Rigor, thank you so much for a tier 1 subscription. Thank you. Really appreciate all the subs. Even though I don't get any money from that, but there is an option from which I can get some money. Just check out the donate command. So yeah. Anyways, so let's actually go ahead and try to use this entire library. Let's actually do include raylib.h, because that's what this example recommends you to do. There is a lot of comments in here, which makes it readable, which makes it difficult to read. So can I do toggle truncate lines? Yeah, there we go. So basically it's not going to wrap around anymore. Okay, so let's have screen width and screen height. So I probably want to have something, I think I want to have this kind of resolution. I think it makes more sense. All right, so here, this is a Raylib. What I want to put in here, your mom, right? As usual, classic. So now let's cap the FPS to 60, right? So we're capping this stuff to 69, to 60. I want you to say to 60. Right. So while window should not close, what we're doing is we begin the drawing, right? So begin drawing. Right. So maybe I'm gonna put a scope in here to have some sort of an indentation, right? So and then we end the drawing process. Clear background, and we have to supply ray white, right? Whatever that means. I don't really know what that means. Maybe it's a custom color. It's a specifically like, you know, the white that is used throughout this website, because it's not really like pure white, right? It's a little bit grayish, so to speak. Maybe that's the color. Maybe that's what it is. So, and let's actually draw the text. Right, so let's see how we can draw the text. So we have to provide some numbers. So I suppose this is width and height, or maybe X and Y, and this is the size, and this is the color, light gray. Okay, so let's actually go ahead and do that. It's like your mom. So here I actually want to do something like a screen width divided by 2 and screen height divided by 2. So the size is going to be, let's say, 69, light gray. Right. So, and the last thing we have to do is just close the window. To be fair, this thing already feels more simple than even simp. I'm sorry, John. But yeah. This is actually simpler than simp. Alright, so yeah. So I just nuked myself out of the giant beta. So please don't show that to John. Alright, so let's actually create a build sh. Right, so and let's do bin s. What the fuck is going on? So if I try to do something like clang main.c, this entire thing is definitely not going to work, right? Because you need to supply some flags, right? So that's very important. So let's actually observe that. So as you can see, it doesn't even know where Raylib is located. So usually what I do, I just use package config to get that information, right? So I just do Raylib and I say, give me the C flags, right? Give me the C flags. But one of the problems here is that it cannot find raylib.pc, which has all of the descriptions of the flags and libs and stuff like that. But this entire thing is located within sort of the installation that we have in here. So if we do grep, actually we need to find file with that specific name, and here it is located within like lib package config blah 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 blah, right? And here we have all of the flags. So if I remember correctly, package config, right, had some sort of a variable, yeah, package config path, right? So one of the things we can do in here in the build sh, we can just say, okay, so package config is essentially at home opt raylib, right? Opt raylib, and it's located somewhere in lib package config. Yeah, there we go. So let's actually put the stuff in here, so it should now kind of work, right? So, and if we, let's actually put it in here, package config C flags, package config C flags raylib, right? And if I try to build this entire thing, there we go, it actually printed the flags, right? So it provided the include flag, so it should be able to find everything. So what we can do now, we can take this entire thing and shove it into the command line of the compilation. So now it will be able to find this entire stuff, right? So, but as you can see, it can, the linker now complains that it cannot find these sort of functions. To fix that, we can also query package configs and say, give me the libs, right? So give me the flags necessary to link with this specific library, right? And here are the flags. So it gives you the path to the libraries, right? So in here, and the flag that tells you to link all of that. Right, and we want to put that stuff somewhere in here. So it's not particularly convenient to put this entire stuff inside of the build script. One of the things I usually like to do, right, is to have sort of like an environment script, right? As you can see, I have that environment script for free type. And what this environment script does, essentially, it sets all the necessary environment variables for this thing to work. Right, so, and I want to create a similar thing for Raylib. So let's actually create raylib.env, and this is where I'm going to move this entire thing. So, and how do I usually use this kind of environment scripts, right? So I do source, which basically, right, executes everything inside of that script in the current shell session. So that means if I do end and build, it will automatically work. As you can see, it automatically worked. So the linker still complains about some other functions, but it doesn't really matter. Right. So, and why do I want to do it like that? So the problem is that somebody may have Raylib installed in a different place, and somebody may have even Raylib installed system-wide, right? So they don't really need any of these kind of tricks or anything like that. So we want to have a build script that works pretty much for majority of the cases, but at the same time I have my own custom environment, and for my own custom environment I have this separate script. Right, so this is basically how I do that. So this is the brain damage that I got from using NixOS for 5 years. Yes, I've been using NixOS for 5 years, and this is a thing in NixOS, which is basically you have packages that are installed in separate, folders, and then you have sort of like a system that builds up the environment out of these packages, setting up the environment variables and also symlinks and stuff like that, and that damaged my brain irreversibly, and that's why I'm doing these things like that since then, even though I don't use NixOS anymore. So yeah. Does that make sense? So yeah, anyway, so we've got even more subs. So I don't remember, I think I already acknowledged Ribirigor. Thank you, Xenos, Ribirigor, thank you. Jie Yang, thank you so much for 47 months of tier 2 subscription, another OG of this channel, with the message, I hope Mr. Jeffrey Bezos appreciates my money. I don't know if he does, but I do appreciate your intent. Thank you so much. Thank you. Maybe one day I'll get those money. We'll see. Thank you so much, Mike Rosoft, for a tier 1 subscription with the message Tsodin cool. That is Tsodin cool indeed. That is Tsodin cool. Okay, so it still complains about some other scheiße. So let's see what is it complaining about. So it cannot find things like sqrtf and cnsf, and we know what that is. That is basically the mathematical library, right? So, and now it complains about something from GLFW. So let's actually also link it with GLFW, right? And it still complains about DL close. So if I remember correctly, like DL stuff is located in DL, so you have to do LDL, right? So, and now it complains about pthread. Okay, that is interesting. So it also wants to have like a pthreads. Let's link it with pthreads, why not? And now it compiled. Would you fucking look at that? We managed to compile it, and if I run this entire thing, it says, yo mom! That's it. We successfully built Raylib from scratch, and we successfully used it. So that's actually kind of cool. I really like that. So, yesu, kawaii. It's not really centered properly because it like renders it like that in here, but... So what I really care in our specific case, what I really care about in our specific case is how can you draw the circles, right? So let's actually take a look at the header, right? So as far as I know, you only have like 3 headers, so the main thing is in Raylib. Do you have circles, my friend? Okay, so there is a draw circle. Let's actually put it in here. So, because that's what the neural network visualization consists of, right? It consists of circles. So, center, where are we gonna put the center on? Let's actually put it at screen width divided by 2 and screen height divided by 2. So the radius is gonna be 100, and the color, I wanna have like a red color, but I'm not sure. Do we have the colors somewhere? Oh, there we go. So there's literally a red in here. Right. So yeah, that's kind of obnoxious, right? So imagine the library actually taking away from you the word red. So that's kind of okay. I mean, you can always undef it if you don't like it, but it's just like kind of anyway, so let's actually try to draw the circle. I'm gonna comment this thing out, and I'm gonna do build main, and it's so also one of the things I have to do source opt array environment, and there we go. So that works. That's a flag of Japan. How about that? So that's pretty cool. No anti-aliasing. What the fuck? Absolutely literally unusable. Literally, I'm joking actually, but I mean it's fine. It's actually kind of cool. I think so. What does it use for drawing actually? Right. I think it uses OpenGL. Right. So let me actually see. So if I take a look at OPT, actually, software Raylib. Let me find the implementation of the draw circle. So let's do draw circle. Holy shit. Okay. So draw circle. I actually only care about the draw circle, like just draw circle. So I don't think it's that much. So okay, so there is this thing, and it just calls the function draw circle v, right? So try to find that draw circle sector. What do we have in here? And okay, so we have segments and stuff like that. Okay, we have RL. Okay, this is actually interesting. This is not JL, it's RL. Right, it's okay. This feels like immediate mode OpenGL, but this is not OpenGL. This is a custom thing. Right. So that's actually kind of cool. Right. So let's actually find RL. I think I know. So there is a header in here called RLGL. So maybe that's what it is. A multi-OpenGL abstraction layer with immediate mode style. Okay, so that's actually kind of cool. So RL begin, initialize. Okay. Wait. Does it use OpenGL? Literally uses OpenGL 1.1? It's actually it's actually fallback. So maybe there is a different version. Okay, so there is a different version in here, and in a different version it uses like a different thing. It uses a custom renderer, with batches and stuff like that. Okay, so that makes sense. It's kind of cool. So if you run this thing on OpenGL 1.1, it uses the immediate mode OpenGL 1.1. But if you have a high OpenGL, it just basically adapts that stuff. Right. So that's actually kind of cool. That's actually kind of cool. Okay, so that's kind of cool. All right. So what I want you to do actually, so let's actually go ahead and like initialize this entire thing. In the nn.h, right? So we have visualization in the header, right? So we have the visualization in the header. So we have the renderer in here, right? So, and what I want to do in here, I want to actually port this piece of code to Raylib, right? So how can we even do all of that? So, all right, so I'm gonna go and just open this entire thing. So what's going to be the resolution of the screen? So we already kind of have the resolution here. So we have image width and image height, which is something that we can use in here. Right, so I'm going to start initializing these things in here. So here we're going to do header, right, set target FPS. Right, so this is going to be 60. But the question is, at which point we're going to be initializing all of that? Right, because here is the thing. Here is the thing. So we have like a bunch of iterations in here, right? We have a bunch of iterations, but then we need to organize some sort of an event loop, right? We need to organize a sort of event loop. And when do we do one single iteration like of backpropagation, right? When do we do that? So maybe we should actually run the training process in a separate thread. That sounds like a good idea, believe it or not. I think like running this entire stuff in a separate thread could be an interesting idea. So, and then in like the event loop in the current thread basically periodically like looks at the state of the neural network and just like draws that state specifically. Right. But maybe I'm gonna do that a little bit later, right? So let's actually try to do that a little bit later. So what I want to do for now is maybe just like transform this entire thing into an event loop, right? So let's just transform it into an event loop and see how it is going to go, right? So let me go here. So we're gonna have while window should close, right? So we're not going to do any logging in here, so I want to actually remove all of the logging. So here we have like saving to like a separate file. I'm not sure if that's very useful, so we probably want to do the rendering in here instead, right? So that's probably what we want to do. We want to do the rendering here. We're not gonna be using finite differences anymore because they're very slow. So we're only gonna like lean towards backpropagation. Right? So that's what we're gonna be doing. Okay, so maybe what I'm gonna be doing is essentially just have it like so, right? And maybe we're gonna have like an I in here, which is initially 0. And if I is less than 5,000, we're gonna do backpropagation and learn and increment I by 1, right? Essentially, if it goes over 5,000 iterations, right? So it will stop learning, it will stop doing things, right? And in here, what we probably want to do, we want to do the actual rendering, right? So let's do begin drawing. Let's also clear the background and end the drawing, right? But on top of that, I want to do something like maybe and then render Raylib, right? And what I want to pass in here, I want to pass the neural network, right? So, and as you can see, it already kind of like namespaces the function calls, right? Because everything in my application uses the snake case, but the Raylib uses the Pascal case, and that's a very interesting way of like, yeah, namespacing this entire thing. Right, so that's actually kind of cool. Okay, so what I want to do is basically copy paste this entire thing, this entire rendering that we used with Olive-C, and I'm gonna just remove it, right? So this is gonna be simply Raylib. Oh, look at that, by the way, we already have a fill. Maybe that means I need to remove clear background, right? And just like use the background color in here. Okay, so we want to actually port the colors here as well, right? I want to like render it similarly to how we render these images in here, right? So yeah, so I want like to use even the same colors in here. I think that makes sense. So to do that, we'll probably have to do the usual thing, right? So we need to find the colors. We need to find the colors. Okay, so how are they defined? Clitoral? What the fuck? What the fuck is clitoral? I'm 13. So it probably stands for C literal. Why is this so funny? So yeah, okay, so C++ does not support compound literals, and okay, I see what they're trying to do in here. It's just like a difference between C and C++. So compound literal. Jesus, what a name. Okay. Okay, so so this is essentially, yeah, it's basically designated initializer or something like that. And for the color, right, so where the color is defined, so do we have like maybe color? Yeah, there we go. So you have RGBA. Okay, that makes sense. So what I usually like to do, right, so here we're gonna have a color. And again, okay, so it like literally took away the name color. Not really big fan of this kind of stuff, but yeah. So this is gonna be 18, 18, and just FF. So that's the color we're gonna have in here. So this is a low color, which is basically purple, right? So if I'm not mistaken. So in here we actually put the alpha to 0 because of how we blend things, but maybe Raylib has a better way of blending things, so we're not going to do that in here like that. So this is going to be FF, this one is 0, FF, FF, there we go. And so this is going to be, so the high color was actually green, right? So that means we have to do something like this. And this is going to be alpha. Maybe I want to even do a line. There we go. And then I can say clear background, and I can just set the background color. There we go. So isn't that poggers? I think it's pretty freaking poggers. Okay, so let's actually try to compile this entire thing, and I'm pretty sure it's going to complain in all of the places where we need to change things, right? So let's go and just do the build. So we have implicit declaration. Okay, so essentially one of the things we'll have to do, we'll have to do the usual setup that we established in a different build SH. So we'll need to port these things in here. Right, so let me actually do the following thing. I want to have separate like variables, C flags and libs, which are going to contain all the necessary flags and libs and stuff like that. So one of the things we want to put in here is this, right? So that's kind of important. For the libs we can put this stuff in here, and here we're gonna do C flags and libs, and there we go. So then later we can add all of this package config nonsense, right, that we established earlier, I mean, right? So, and in here, all of the lib stuff, right? We already linked with pthread, so that means it should be actually super easy to make the entire process multi-threaded, meaning that we can learn in a separate thread, and the UI thread is also a separate thing, and it periodically just looks at the current state of the neural network and just displays it, right? So we already link with pthread, so why not just use it for our purposes? I think that makes sense. So maybe here I want to actually put it before I enable the tracing, so it doesn't really trace this entire stuff, but maybe it doesn't really matter, right? So it's better to trace everything just in case, Alright, so if I try to do this kind of stuff, W all not found, yeah, and this is because you have to actually wrap this entire stuff in quotes, because welcome to bash, right, so welcome to bash. And as you can see, so it cannot find the Raylib PC because we have to use the corresponding environment, right? So we have to do something like this, opt Raylib env, and if I try to do it now, it seems to be working, How about that? Right, so it cannot find image width because we don't pass any image here anymore, right? In the previous version that used Olive-C, we actually put image in here, right, which contained the width, but this one doesn't contain the width. But we know the width and height of the window, it's literally image width and image height, right? So that's basically what we have in here. And might as well, maybe, you know, I think I need to actually do query replace image width is image width. There we go. It's actually not that many, so I suppose that's the only place where we have to do that. So what's the other thing? So here we are actually, you know, blending the colors, and the question is how should we blend that? So the actual sort of alpha, right, the actual alpha that we computed in here is this, right? So that's the actual alpha. So I suppose one of the things I can do in here, I can just take the high color and set it alpha to this. Maybe even cooler, just set it like this. All right. And no, it doesn't really blend these two colors together. That's the problem. It doesn't really blend it because we're not drawing them on top of each other. So we need to find something that would blend this entire stuff. So Raylib include. So do you have anything for blending the colors? I actually kind of doubt that. Blending. Okay, so there are blending modes. But how do you use that? Okay, blend. Begin blend mode and blend mode. Color. Ooh, get SOC alpha blended into DST color with tint. Not, I don't quite understand why do you need to do tint in here. Right, but that kind of looks like what we need. Is there any other blends? No, this is the only thing in here. SOC alpha blended, so this is the source, into DST color with tint. So, because I don't really need tint. Right. Color, tint, color. Maybe there is something like mix. No, there's only blend. So color alpha blend. Set the color alpha aligned. So I kind of want to take a look at how exactly this entire thing implemented. Right. So let's do this thing. So include, where was that? So Raylib. I think it's in SRC, right? There we go. Raylib dot. Yeah. So essentially, what I want to find the implementation of that specific function, right? So let's actually try to find this kind of stuff, right? Let's try to find. So our textures, right? So what we're doing here, we're essentially adding the tint. We're multiplying this thing by the tint plus 1. And then, I suppose, we're blending all of that. So if I set the tint to 0, right, if I set the tint to 0, that just means that it will be added to 1, right? It will be added 1, and then multiplied by this entire thing using the original color. Right, so that's what I think it will do, but at the same time, it also shifts this entire stuff by 8, which doesn't make much sense to me at all. Like, why do you shift it down like that? So let me see. So this is integer, right? So maybe what we have to do is use the white tint, right? Use the white tint, and essentially that will kind of overflow and we'll end up with the same color. It's kind of the excuse me. So I have this sort of idea. Yeah, I think using white, pure white, is the way to go. So let's actually quickly do that. How are we going to be doing all of that? So I think this is where setting the alpha to 0 could be actually useful, right? So this is where. So the destination color, yeah, I think I can set it as the low color, right? And this one could be high color. And the tint, I'm gonna set the tint to white. Does it even have the white? That's the good question, right? Do we have a Raylib.h white? Yeah, okay. So, and Ray white is sort of like a different white. My own white Raylib logo. Okay, that makes sense. I can't get over this goddamn freaking clitoral. I swear to God, this is done intentionally. This is done intentionally. Freaking clitoral. Anyway, I'm sorry. Again, I'm 13. Like, I don't know why it makes me laugh so much. So this is the color, and we blended this entire thing, and here we're trying to draw a line. Okay, so that kind of makes sense, right? So that kind of makes sense. So this is a connection color, so probably doesn't really matter. And might as well just set this entire stuff like this, right? So this is a high color, then we blend, and that creates a new color, right? So that creates a new color that we can then use for the line. So how do you draw a line? Can I just do draw a line? Perfect. Perfection. Okay. So, and essentially this is where I can put that color, right? So, and we're starting to draw since CX1, CY1, CX2, CY2. There we go. So we just ported this entire stuff. All right. Okay, so how can we build this entire thing? All right. Okay, so this is a similar situation, right? Very much similar situation, and I think I'm going to simply copy paste this entire stuff. So here we're drawing circle, right? So let me grab draw circle. We already know that drawing circles actually works, right? It actually works. And so here we're doing a neural color, right? So that means neuron color, low color. Honestly, I think a neuron color, and where's the neuron color? I can't spell it. Neuron color. Yeah, it's just like literally low color. Yeah, it doesn't really matter. So here what we have to do, it's a high color. This is the alpha of that thing. I'm an idiot. So I'm actually modifying the wrong thing. I'm modifying the wrong freaking function. Wait, was I modifying the wrong thing all along? Okay, so I'm going crazy. So it's a completely different thing, right? Oh boy. Right, so let me bring the draw circle back in here. So I'm gonna remove this entire thing. So we're blending the colors. So this is the alpha, we don't really need that. And the only thing we need in here is the color blend. I'm gonna put the stuff in here. So CX1, right? So this is CX1, CY1. And in terms of the radius, we have a neuron radius, right? So this is a neuron radius. So that's what we have in here. So, and for this entire thing, we just use gray, right? We just use gray. And let me maybe go ahead and express that. So maybe it's just like literally going to be gray. So that means the color scheme is not going to be precisely the same, but it's going to be close, right? It's going to be kind of close. All right, so what else do we have in here? So, undeclared identifier J. Are you serious? Why it works in here then? Did I accidentally remove something? Oh yeah, I see. So this is because, yeah, we should have not copy pasted it like so. So this is a J. Yeah. Just a second. I need to go here, and that's the actual value that I have to put in here. So I think that is going to work now, at least here. And this is, yeah, we don't have to. Okay, so I'm having a lot of brain farts, but that's fine. Okay, so this is screen width. It has to be image width, image height. All right, and is it going to work? I think it's going to work. Yeah, there we go. So it works, but it complains about like STB stuff. Not really sure. Multiple oh, okay, that's actually kind of cool. Raylib is using STB image write, so we can't link it with STB image. Luckily, we don't really have to, right? Since we're migrating to Raylib, right, we don't really need that stuff anymore, so we can just basically remove this thing. Right, so let's go ahead and do that, and that should be fine now. Yeah, there we go. So, so let's actually try to run this entire thing. So let me double check if it's going to work properly, and how exactly is it going to work. It's going to be learning slower. It's going to be learning at 60 FPS. Imagine a neural network that is learning at 60 FPS. Isn't that poggers? I think that's pretty freaking poggers. Okay, so I'm going to try to run it. And is it doing things? It's kind of hard to tell. Like, I don't see it doing anything. But yeah. Oh, this is actually kind of cool. So once we close it, it will try to verify it and just confirm that it's actually doing something. Okay, so we can't really see if it's doing anything. Right. So maybe one of the things we have to do in here, we have to print the cost function of this entire thing. So let's do nn cost. And I don't quite remember nn.h nn cost. Right, so it accepts the neural network and the input and output in here. There we go. So let's actually go ahead and just try to do that. So we're going to be building and then running the entire thing. So yeah, we just need to see if it's actually doing something. Well, it's actually kind of doing something, but now it's stuck. I wonder why. Right, it's probably because this entire thing is dumb. Right, that's kind of weird. It should be actually way better. Let's remove some of the like internal things. Maybe this is because it's like too many internal layers. That's probably the problem here. All right. So is it going down? I think, yeah, I think something is actually, yeah, there we go. So they are appearing. Yo, this is so cool. Look at that. It is learning. It's actually changing its weights and biases. That is so cool. And we can see that in real time. We're literally seeing that in real time. This is so freaking cool. Yeah. Okay. So then we can probably close. Let's actually wait until it actually gets to a decent level. So since we have a UI now, we can actually plot the cost function somehow, right? So we can actually plot it. All right. So now, if I close this entire thing, it's going to verify it and say that it's totally okay. All right, so now we're able to actually like render this entire thing in real time without like, you know, taking a snapshots or anything like that, right? So we can just do it like this, right? So, and that means we don't really need Olive C, so we only need the nn.h and Raylib, and there we go. So I'm going to just try to recompile this entire thing. So yeah, it will require probably remove a couple of things in here. Yeah, there we go. And now it is learning. Man, this is so freaking cool. I love it. Yo. You can like literally see how it's just like, you know, gets to some point. Right. So as far as I know, like the purple ones are the ones that are sort of get disabled, right? Because the closer it is to 0, the more it's disabled. Maybe we can even try to sort of like emphasize that by using literally a gray color for the low color. That's one of the things we can try to do. Right, so let's actually quickly try to do that. Yeah, so initially everything is sort of like a green, and then some of them are gonna get disabled, right? So they're slowly getting disabled, right? And that creates sort of like a certain pathways. Wasn't -1, it is able to, we're using sigmoid activation, right? So, well, not really. So maybe it's not particularly representative of what's going on in here. Yeah, so grayish means they're negative. Right, grayish means they're negative. Alright, but maybe it would be better to just keep purple. I think purple was a little bit better. Okay, so but here is the interesting thing. So the nn.h is supposed to be a header-only library, right? So, but to have this sort of visualization stuff, we need a whole freaking dependency in terms of Raylib, which doesn't really make any sense. What I'm thinking is that, what if the visualization tool is going to be a separate self-contained program specifically for training neural networks? Here's an interesting thing. What I noticed while making the neural networks with the nn.h is that the structure of the program ends up being the same. It literally ends up being the same. So you have some training data, right? So then you allocate a bunch of neural networks, right, with a certain architecture, and then you just have a loop that trains this entire thing. What if we turn this entire stuff into like a self-contained application where you can customize all of that stuff, where you can say, okay, here is the file with the training data, here is the description of the architecture of the neural network, right? So basically a bunch of numbers like that indicate the sizes of the layers. Go ahead and train that neural network on that data, and it will just start visualization, right? It will show how the architecture that you described actually like evolves and stuff like that. And then it saves the trained neural network on a hard drive, where you can then take that neural network, load it into your custom program, and integrate it and use it, right? So in that regard, nn.h can be used for integrating these neural networks that are trained by this sort of like separate application, and that separate application also uses nn.h. Does it make sense? Right. So let's actually come up with the name for such application. So we're sort of like having a separate place for training neural networks. Let's actually maybe call it like a gym.c, and it's going to be the graphical application that just like shows the training process, right? So yeah, essentially like I'm gonna outline the basic architecture that I sort of like envision. Sort of like envision. So I started my paint. Okay, so here it is. So essentially we have an n, just a second. And n.h, right? So this is basically the header-only library. Then we have a gem, right? Gem that uses nn.h, right? That uses nn.h, but on top of that, it also uses Raylib. Raylib. Right. So that's what it does. So what you do, right? You give it the data, right? You give it the data and the description of the architecture, right? So the arc, the architecture of the neural network. So you give all of these things to the gem in the form of files, maybe, right? So that's why I'm sort of like drawing it with the rectangles to indicate that these are not libraries. These are libraries, library dependencies, and this is sort of like the files. You give all of that stuff to this thing, right? And it spits out a neural network in the form of a file, right? So in the form of a file. So that's what you have. So, and it's a abstract application, right? That just, you know, trains your neural network. And then you have your app, right? So you have your app that also uses nn.h and basically uses this trained neural network. So that's basically the architecture that I envision right now with the Raylib. And as you can see, with this kind of approach, nn.h does not depend on Raylib, right? And your application also doesn't depend on Raylib, right? So it's still a single header-only library, right? So it's used to create this sort of like a neural network, and then you can integrate this thing into your application and sort of deploy it. nn.json, yeah, maybe it's going to be nn.json, right? Who knows? But maybe this thing should be like a single file. But I don't think it's that good of an idea, right? I would like to separate the architecture and data. And again, I'm not an artificial intelligence person, right? I'm pretty sure there's some sort of like a conventions and standard developed over the years of doing this entire stuff. But that's where this entire thing sort of wants to converge, if that makes any sense. There is a thing that I keep talking about, like on my streams almost like all the time, is that when you're developing a certain application, your source code sort of wants to converge to a certain architecture. It's sort of like the requirements of the application dictate the architecture of the entire thing, if you know what I mean, right? So you basically have requirements, and you start iterating on these requirements, and the code base sort of emerges out of the requirements. And what's interesting is that it's kind of similar to how the neural network learn, you know? So you have the data, and you're just trying to optimize the cost function. And by trying to optimize the cost function on that specific data, a certain architecture just emerges out of nowhere. And it's kind of similar, right? So it's just like you are the thing that you can view your code base as the neural network, right? As some sort of a model. And you are training it on the requirements, and by trying to feed this entire thing into requirements, a certain architecture emerges sort of by itself, right? Which is kind of like, yeah, it's kind of like similar in a sense, if you know what I mean. Does it make sense? Does everything I say make sense? Right? And that's why when you're trying to architect upfront, it rarely works, because whatever you're trying to architect upfront doesn't really correspond to the reality, doesn't correspond to the requirements. It's not by itself, but it's a very similar process. Yeah, so it's not by itself, but it feels like it's doing by itself. If you programmed long enough, and you programmed like very complex applications, you probably know that sometimes the code just wants to do its own thing. Like you are, of course, you are modifying the code, you are like the programmer, you are in control of these things, but sometimes it feels like you're very limited in terms of what you can do, and those limitations kind of give the code the character, if that makes any sense. So it's just like codes wants to do its own thing, right? So, and at some point, when you zone out and you program, it feels like it's just like the code just writes itself, right? And it feels alive. Who's the boss of the gym? That's a good question, actually. Who's the boss of the gym? Right, and the gym itself can also contain not only visualization of the neural network, right? It can also contain the cost plotting, right? And stuff like that. Is it whiskey? No, it's a green tea. It's actually oolong tea, right? So I don't drink alcohol at all. Like AI, the code steals your job. Well, nobody can steal your job if you don't have a new job. Smart, right? So I quit my job 5 years ago because I knew the AI is fucking coming. Just like Billy Harrington, it's fucking coming right now. Right, so, for your job, of course. So let's actually implement... What the fuck is wrong with me? Holy shit. Twitch is the job, but I mean, it doesn't even pay, right? So it's just like I'm literally shitposting on the internet for free. So I literally don't have a job. Okay, guys, so we're gonna have Raylib.h and let's do this kind of thing. So, okay. Gym is is a GUI app that trains your NN on the data you give it, right? The idea is that it will spit out a binary file that can be then loaded up with nn.h and used in your application. Right, there we go. So that's basically the sort of the main idea of this entire stuff. GIM stands for GUI your mom. Oh. All right. So what we're gonna accept in here, I suppose we're gonna pass the files with the description of the neural network and the data in the command line arguments. So maybe in the future we're gonna have some sort of a UI that will let you just pick the file from the file system, and you don't have to pass it through command line arguments, but I don't want to research how to do that right now. By the way, I remember Raylib had something for UI, if I'm not mistaken. Oh, RayGUI, yeah, Rogue, yeah. So it's a simple and easy to use immediate mode GUI library. Was originally inspired by Unity IMGUI. Okay, Unity has its own immediate GUI. That's very interesting. So yeah, who needs dear IMGUI when you have this shit? Where is this thing? Yeah, it's not poggers. I think it's pretty freaking poggers. Look at that. Yo, that's so cool. We should definitely try that at some point. Okay, but not right now. A little bit later. Okay, so I'm gonna start copy pasting the code from the editor and stuff like that. So obviously I'm gonna just have this thing in here, right? So this is the sizes of the window, right? They are super important. So here we have to initialize the window, right? So this is gonna be gym, right? So this is a gym, and here we're doing this kind of stuff. Yeah, it probably makes sense to also copy paste this kind of thing. Right, so we need to come up with the format on how to describe the architecture of the neural network. The thing about the architecture of neural network, at least right now, is that it's just a sequence of numbers. It's a sequence of integers, I would even say, right? If you know what I mean. Right, so essentially we could say that we have an adder right, and let's call it adder.nn or something like that. And so we could say that you have like a 4 inputs, right? Actually, you need to have like 4 things in here. Because if first 4 bits are the first number, the second 4 bits is the first 4 bits is the first number, and second 4 bits is the second number, right? So that means that the input is going to be 8 neurons, right? So then another thing we want to have in here is probably just say maybe 16, like a hidden layer, and then we're going to have like a 4 bits as an output and +1 for the overflow bit, right? We need a way to describe this kind of stuff, right? But describing that with numbers, as you can see, is not particularly convenient, because you kind of want to have like arithmetic operations, just for the reason I said, right? So just for the reason I said, because you may want to have like something like n equal to 4, and then you can say that the architecture of this neural network is essentially 2n, n by n, and n plus 1, right? So you want to be able to say something like that when you're describing your neural network, right? Because you want to kind of give the meaning to all of these numbers, if that makes any sense. So what would be the best way to actually like describe this entire thing? So that means that the gym has to have like a simple interpreted language, if that makes any sense, right? But do I really want to go that route? Do I really want to go that route? I don't really know. I don't really know, right? Because it would be better if the gym was some sort of like a separate library, but it depends on Raylib, which makes it kind of, yeah. So this entire thing naturally wants to have like a scripting language, right? So the description of this stuff needs to be like flexible enough. Right, it needs to be flexible enough. But maybe for now, just for now, we're going to be using numbers, right? So, and then later, I'll see what we can do about that. Maybe we could make some sort of like a stack-based language, like a fourth style language, where I could say, okay, 4, 4, all right, so basically maybe 4, 2 multiplied, so this is the first thing, and then 4, 4 that, and then 4, 1 plus, or something like that. And then here you could say let n be equal to 4 or something, because like interpreting the stack-based languages is a little bit easier, right? But anyway, so for now I'm gonna say it's gonna be 8, 16, and 5, right? So the first thing we probably want to do in the gym is read this entire stuff, right? So we want to read this entire file. AI porth, it's all coming together, yeah. Right. I don't know if I really want to develop another programming language, but we'll see, we'll see. So we need a way to maybe read the entire file. So let me go ahead and steal reading the entire file from some places. I think I had that in Olive C. Right, so there was there a read entire? There was a write entire file. Okay, so we don't really have that in here. So what else? Maybe dead, right? So maybe we have that stuff in a dead, in a common, read entire file. So I'm gonna actually steal this entire stuff. It's actually read entire dir, right? So read entire file. Let's take this entire thing and it uses string builder, which is kind of meh for our case, right? Because it will require taking too many things with all of that. So do I want to really go that route? So this entire thing also wants to have file size, which is fine. I can give it to it, sure. So this is the capacity, so we just do reallocation. Yeah, I don't really want to use the string builder, so let me try to compile this entire thing. So I'm going to do build sh. For now I'm going to just put it like that, and in here we're going to just have a gym. Okay, alright, so let's go through all this entire stuff. So if I remember correctly, I typed deft error no to integer, right? What else do we have? File, so that requires including stdio. By the way, maybe Raylib has something to do with files. Does it have something for reading files? So file path. This one is interesting. Okay, file path, load file data. So this is the callback stuff. Right. Is there something like load file? No. Yeah, I don't think it's load file data. This is actually convenient. Okay, so maybe we can just use this entire thing, unload file data located in load data file. Huh. Yeah, so since we're using Raylib, we can just use this entire thing. Okay, so that's actually kind of cool. Let's get rid of this stuff. Right, because it makes it even more cross-platform and everything. Well, I mean, C is kind of already cross-platform, but whatever. So this is the buffer, and we're going to provide the file name. So I already have header.nn, right? So header.nn, and in here we're going to have something like, so this is unsigned integer buffer len, and I'm going to pass this entire thing in here, buffer len. So initially 0. We're going to put the pointer in here. That's actually kind of cool. And we can do fwrite. Let me take a look at how we do fwrite in here. Header.arch maybe. Yeah, we'll see. I'm not really sure how exactly, like what kind of extension to use exactly. But maybe arch actually makes sense. Yeah. So let's actually change it to arch. Yeah, that makes sense because it's architecture, not really the data. It's just a basic architecture. And I'm pretty sure this format is going to evolve over time because this assumes fully connected neural networks, right? So, but there are different kinds of neural networks. What if our library is going to support like convolutional neural networks? And convolutional neural networks are described differently. Furthermore, there are sort of like a hybrid neural networks. Is that even a term that AI people use? But as far as I know, quite often people at least used to do, I'm not sure how common it is today, but they used to like have several convolutional layers as the first layers that sort of perceive the image, because it's usually for images. And then at the back end, they have fully connected neural network that sort of has the logic on the convolutional neural network. So the convolutional layers sort of compress different things and filter out. And then you have the decision making with the fully connected. You mean high dimensional? I don't know. I'm not an AI person. I don't know the terminology. So how do you call the neural networks that combine convolutional neural networks and fully connected neural networks? Is there any term, sort of like a hybrid ones? Heterogeneous? Because you can come up with a lot of pompous terms to sound cool to your investors. So I don't know which of the pompous terms the AI people chose to call this kind of stuff. Like, because I'm not in the industry. Like, I don't know, like, your conventions. So... I can't remember a term for them. Like me neither. I don't know. Like which term actually gives you more money from the investors? Like which one like sounds cooler? Like I don't really know. It looks like hybrid is actually used in some papers. Nice. Okay. So I guessed the pompous term correctly. That's cool. So that means I can already work in AI industry because that's what's important. Because otherwise, how can you get the money out of the investors? If you can't get money out of the investors by constantly using these pompous five-head terms, you won't be able to even do anything, right? Because you can't do research if you can't eat, right? So that's why the terms, the cool terms, are way more important than what you do, because that's what gets you money. I'm joking, by the way. I'm just joking. Don't get me serious, okay? But I know how it works. I know how it works. I worked in other industries. Anyway, so just poking fun. Right, so let's actually write this entire stuff. Buffer. So this is the buffer len, and then we're gonna have like 1. So, and I just want to see if it actually like reads the entire file, right? Just want to see if it actually reads anything. So let's comment this stuff out, And let's do the gym. Let's show it who's the boss of the gym. Failed to open file because it's not header.nn. It's actually kind of cool that this entire thing automatically logs everything for you. Yo, this is so cool. You were joking, but similar happened at my work recently. We had to describe a multi-threaded job system in a fancy way to impress stupid people. Yeah, I know. Like, I'm joking, but I'm actually half joking, right? So, because I've seen how that happens. Like, I've seen how that happens. I know how that works. And because of that, if I meet people from other sort of areas of like work and like IT and stuff like that, and they start throwing all of this fancy pompous term, I know what they're trying to do. I know, because I fucking know how that shit works. Like, you're not gonna fool me with all of that stuff, right? Because you can always describe the same thing with simpler, easier to understand terms. You can do that. You just choose not to do that for certain purposes, for gatekeeping purposes, for impressing purposes. Like, I know how it works. Just, yeah. Anyways, so okay. Arch. Cool. We managed to read that shite. How about it? How about it? So the next thing we probably need to do, we need to parse this entire thing, and maybe I'm gonna just use like something like as sv.h, right? So this is the is it just a sv? I think it's just a sv, right? It's another single header library, right? So you can find it in here, and this is just like for string views. People keep sending me pull requests, but I don't have time and resources to actually look into them, so I really apologize for anyone who sends the pull request and I don't really look into them. Right, so let me just download this entire thing. It's actually very convenient for parsing in general, in C specifically, and I use it for that. Finally! Wait a second, did they just edit the download button? What the fuck? I mean, wait a second. So, like, this website exists since 2009? Since 2009. It's over 10 years. Holy shit, it's almost 15 years. And it took them more than 10 years to come up with this revolutionary feature to download a raw file. Holy shit. It took resources of multi-billion corporation, because before they got bought by Microsoft, they couldn't fucking do that. It was impossible computer science problem. And then Microsoft bought them, and they used their multi-billion corporation resources, and they finally came up with this beautiful solution. Holy fucking shit. Oh my god, finally. That's the actual advancement. Not all of that AI hype. This is the actual advancement in software development. Holy shit, look at that. Yo! What the f... Anyways, so... But really, why was it so fucking difficult to just add this button? I don't know. So anyway. So... sv.h. I'm gonna move this thing in here, and there we go. Okay, gym.c. We need to include sv.h, and what do we have in sv.h? We have to also do sv implementation. There we go, define. So what we can do, we can now construct a string view out of the parts, right? So we can say that we're gonna have a string view content, right? So this is a string view content, and the data is the buffer, and this thing is the buffer len, and we may have some problems in here, right? Because the string view sort of expects just a pointer to the character, but we have a pointer to unsigned characters. Right, and we'll see. So let's actually take a look at the compilation errors and what they're complaining about. What are they complaining about? There's a couple of warnings, but I think we can quite easily just say, shut the fuck up, and just like suck it up, and that should be fine. Okay, so we have content. So now, while content is greater than 0, right? While it is greater than 0, one of the things we can do SV chop by delimiter, right? We chop by delimiter, we provide the content, and the delimiter is going to be actually space, right? We chop in by the space, here we get like a single layer in here, right? So we essentially get a single layer, and one of the things we can do now, we can say print this entire thing svarg, right? So an svfmt svarg is a classical thing that I use, right? So essentially it just allows you to use printf with a structure, because string view is a structure, but sometimes you want to use printf with this entire thing, and I come up with a bunch of macros that makes it a little bit easier for you, right? For the formatting you have to use this thing, and svarg basically just destructurizes this structure into several arguments, right? So then you can essentially print it like this, right? So it's kind of cool. All right, so and now I might as well actually wrap this entire stuff in this, right? So we can wrap this entire stuff in this, and let's go, and as you can see, it kind of worked, but the problem here is that it printed this entire thing, and we separated this entire stuff into numbers. We can now parse these numbers. As far as I know, there was, yeah, so you can literally try to do something like this. We can also try to use this thing, chop u64, right, which literally tries to chop a number out of this entire stuff. I think that's even better than just separating it by spaces, right? Because what if you have several spaces, right? If you have several spaces, you're gonna have a little bit of a trouble, right? So let me take a look. So we have like several of these things. You have a little bit of a trouble, right? So as you can see, yeah, so it's kind of dumb, I'm not gonna lie. So what would be better, in my opinion, is to use this thing, which just chops this stuff out of the content, right? So does it trim the white spaces in front of this thing? Okay, it doesn't trim them, but we can do that ourselves, right? So essentially, this is an old way of doing that. We don't care about it. We can do sv trim left. We just trim all of that stuff in the content, right? And then we chop the number, right? So here is the number, and then we basically just print this entire thing, right? So now we should be able to do something like, so this is uint64. Let's cast this something to integer, right? So just to make it a little bit easier, because like uint64 has a special way of printing it with printf, so it's a little bit pain in the ass. So let's actually do it like that. There we go. And as you can see, regardless of the amount of spaces, it just works like that. Though if you have, for instance, no things at all, right, and just a bunch of spaces, it's still going to be rather weird, right? Because it says that you have at least one number in here, which is like not true, right? So essentially what we want to do, we want to have like a slightly different way of doing that. So first thing we do is trim, and only then check if it's empty or not. Only then check if it's empty or not, and then trim again at the end of the iteration. So first we trim, and then if that makes the content count equal 0, that means we stop the iteration. But if it's not, we try to chop the character out of that, and then we continue, and so on and so forth. So there could be some problems if this entire thing starts with, for example, a character, right? Because if I remember correctly, this entire thing just handles up until the digits, right? So this thing may basically hang if you have anything that is not a digit in here, right? So that means that one of the things we probably want to do is content count is greater than 0 and content data 0 is digit. Only then do that. So that will make the entire loop stop as soon as it sees a single character, right? Okay, and that's way better way of doing that in my opinion, right? So here, as you can see, there's no numbers. There's no numbers. We can now put 8 in here, right? So we're gonna put 8 in here, right? So as you can see, there's 1 8. We can even put some stuff here on a separate line. So as you can see, it still works. And then if we put accidentally like a character in here, it will just stop at the character, right? So maybe one of the things we can do is just like make a warning there and stuff like that, but I'm not going to do that. So here we're going to have 5. And as you can see, this is a very robust way of doing this entire stuff. This is a very robust way of doing that, and maybe it will evolve into something interesting in the future, right? Isn't that poggers? I think that's pretty freaking poggers. So, cool. So, but that means we have to now add these numbers to some sort of array, right? We need to add those numbers to some sort of array. So what we're going to be adding that to? We need to have dynamic arrays, right? So, and you know how I implement dynamic arrays. So I usually have a macro. I can steal that macro from dead yet again. So it's going to be src. So I think it's located somewhere in the common. da append, right? So that's a very simple macro. It's a very simple macro that we can just like put in here. So, and essentially what this macro expects is some sort of a structure that looks like this, right? And in here we have to do items, I think. So this is how we do that. So it calls them item, yeah. So this is the items. It should also have the count and the capacity. Right, so and essentially what we can do, we can say, okay, so here's the architecture, it's initially 0 initialized, and then as soon as we read something, so let's actually convert this stuff to size t, we're going to do da append arch x, right, there we go. And now we have the architecture with which we can now construct a neural network, right? So that means we can just like do it like this, arch data arch count, and that should create the neural network for us. We can even randomize this entire thing, and then we're gonna actually print this entire thing like so. There we go. So let me try to run this entire thing, and there's a couple of warnings. So da append, oh yeah, so it wants to have the initial capacity. So let's set the initial capacity to something like 256, I don't know. I think that's more or less reasonable, more or less. Implicit declaration of assert, okay, let's include assert here as well. So here is the assert. What else do we need to have in here? Implicit declaration of an n, so we have to include nn.h and implementation. There we go. So is it working? So it's actually items. So what else do we have? So when we're randomizing, we have to specify the range, right? So basically lower and upper count, upper value, and it kind of worked, but it took a little bit some time. Yeah, okay. So yeah, it's actually pretty cool, and it also logs. Right, file loaded correctly, but yeah, this is basically the neural network that we managed to create in here. And so that means here I can have like other neural networks, right? So for instance, ZOR1. So ZOR1 is basically 2, 2, 1, right? And if I try to restart this entire thing, I wonder why it takes so much time, but yeah. So as you can see, we can specify the architecture of the neural network at the runtime now. Isn't it poggers? Isn't poggers? I think it's pretty freaking poggers. Right, so, and for header, let's actually get back to here. And we can have several like different files for this entire stuff, right? So I think that's pretty cool. All right, so we managed to read this entire stuff. So the next thing we need to do, we need to initialize the window and stuff like that, right? So let's initialize the window. Alrighty. Okay. So adder.c. So we're probably also going to do something like this. So the other thing we need to do, we need to be able to read the data, right? But to read the data, we need to generate the data as well. So the question is, how exactly are we going to be doing all of that? How exactly are we going to be doing all of that? So the input and output data is basically the matrices, right? So where the rows is the amount of samples and the columns are the things. Okay, the columns could be quite easily derived from the architecture of the neural network, right? So here, so we have at least 8 columns for the input and then 5 more columns for the output, right? So that's what we have in here. So that's what we have. The question is, how do we specify the rows? We can come up with some sort of a like binary format. We can come up with a binary format where, for instance, first 8 bytes, right? So you have first 8 bytes, and this is basically the amount of rows in your neural network, right? Maybe we can specify columns as well, right? So who said we can't really do that? So it's gonna be 8 bytes. And then you have basically sequences of 8 bytes, right? Sequences of 8 bytes, like so. Where each byte is the element of the matrix, of this specific matrix. Okay, so this could be like a general format for serializing the matrices, right? So if you have a matrix, you can just serialize it into this binary format and just like dump it and then load up if you want to. Right, it would be kind of also nice to have a magic in here, right? Some sort of a magic. Usually, like, how big of a magic people put in their binary files? I suppose like 8 bytes, right? So this is basically the binary format I'm thinking about, right? So the question is, what's going to be the magic? The magic could be something like, I don't know, nn.h. This is literally 4 bytes, actually. nn.h. So, because what if I want to actually also serialize neural networks, entire neural networks, right? So that means I may have separate magics for that, right? Separate magics for that. So it would be kind of cool to have like m. So this is for matrix, and for the neural network, I don't know. It's kind of difficult to come up. So matrix. Man, this kind of hard. Like, how can you even come up with this kind of thing? And then h.mat, but that's a lot of bytes, right? That's 8 characters, which is probably fine. Yeah, thank you. Right, so it's basically, in that case, it's gonna be 8 bytes. I mean, this is a 2023. Why even worry about you know, this kind of stuff, right? So we can have mat, and then we can have like nn, right? So that makes sense. I think that makes sense. All right, so let's go ahead and maybe implement some functions that will enable us doing this kind of stuff, right? So if we take a look at nn.h, right, so we have mat alloc, you can allocate, you can randomize, you can print this entire thing, and let's actually do something like mat save, maybe, right, mat save, and essentially here, we're gonna accept the file, right? So the output and the matrix, right? So, and it will just like literally save. And another thing we probably want to have is load, right? So this is gonna be in. So this is the 2 functions that we'll need to implement, like save and load. Some of them may fail. I don't really know what we have to do in case of a failure, but we can just crash at least for now. Right. So let's go mat alloc. Let's for now implement only save. Right, so this is gonna be that. Okay, so let's do Right. So we're gonna have something like magic, and the magic is gonna be nn.h mat, right? So there's like 8 characters in here, right? So, and we're gonna just do fwrite output magic and then strlen of the magic, right? So strlen of the magic, and then 1. I think out has to be actually add here. Right, in the case of an errors, what do we do in case of an errors? So we can use the Raylib approach. Essentially, if an error has happened, we just log it and exit. Right, we can say something like fprintf std error, nn.h could not write to file. Right, so could not write to file, but maybe I don't know how useful that is. For now, at least, right? Because we're going to be opening the file outside of this entire thing, and if you manage to open the file, it's usually fine. So there's no need to do this kind of stuff. So maybe, whatever. Okay. So let's do fwrite, and let's actually write the following thing. So the first thing is going to be rows, right? Size of rows 1 and output, and also let's put the columns in here. So this is the columns. All right, so and then one of the things we want to do fwrite. So this is the elements size of a single element, and the amount of elements we have in here is m rows and m columns, right? So the m rows and m columns multiplied to each other, right, by each other, and that's basically the whole serialization. That's basically the whole serialization. So this entire thing may actually not provide like save everything. So I suppose you have to run it in a loop, right? But one of the things we can do, we can kind of run it in a loop, right? Essentially, like while n is sort of like a less than this entire thing. Right, while it's less than this entire thing, we may want to do the following stuff. Right, plus n plus n minus n. Right, and then we read it to another m, and then let go. And also maybe while not f_error out. Right, because if it errors, it may keep returning 0, and we can actually hang in there. Right, is that a good thing? I think that's a pretty good thing. Right, another assertion that we may put in here is basically that m is always less or equal than the current n, just in case, because you never know what's going to happen. Otherwise, it's just going to... actually, here... Yeah, no, I'm doing something stupid in here, I suppose. Yeah, that's fine. That's totally fine. That's actually like perfect. Right. Okay, so isn't it cool? I think that's pretty freaking cool. So let's go ahead and try to write a generator for some data. Unintentional, completely unintentional. Right, so this is going to be a separate program. So I suppose the idea is going to be the following. Okay, so you need to somehow come up with that data somehow. The question is, how are you going to come up with that? That's a very good question. I suppose they're going to be like another, like a generator that creates you the data, right, which you then feed into the gym. Then gym spits out the neural network that you can use in your application. Is that too complicated of a thing? What about the stride? That's a good question. Yes, I should probably take a stride into account. Yeah, thank you so much. So is that too complicated of like a workflow with this entire thing? I don't know. It kind of feels a little bit complicated, but I don't know how else. What else would you do? Right. So if you want to have this visualization tool that just shows you the process of learning, I think that's what you have to do. You have the number of rows and columns, no need for stride. What are you talking about? Is that the words of the person who have no idea how this library works? We do have stride. So, and what if somebody will try to save the entire thing? Right, we do have a stride and we need to take it into account because that's how the library works. And I know how the library works because I wrote it. And the viewer in the chat knows how the library works because they watched the stream. Okay, so I suppose what we need to do in here, so yeah, so let's do this kind of stuff. So let's iterate by rows. Right, so this is going to be rows plus I. So we're gonna put it like this, and the question is, where do we start? I suppose we can do one of the things. We can do mat at, and we can just do m, and then we start at the row I at the column 0, and that resolves the stuff with the stride automatically. Right, so we're gonna do it like this, and here in fact now we're just trying to save columns. Right, so we're just saving the columns, and that means that here, instead of this kind of stuff, we can just do it like that. There we go. Isn't that poggers? Isn't it poggers? I think that's pretty freaking poggers. So, yeah, let's come up with a generator. But don't you need to also save the stride field? It gets lost after serialization. It gets lost after serialization, so no. So, all right. Adder again. .h. It would be kind of interesting to actually store the architecture here as well, if you know what I mean. Because the actual training data is tied to the architecture, right? If you change the architecture, you have to change the training data, and if you change the training data, you have to change the architecture. So it's kind of an interesting thing, isn't it? It's kind of an interesting thing. So maybe we should actually save the whole thing in here, right? The whole. Though no, it's not necessarily, because it's only about inputs and outputs. Yeah, it's only about inputs and outputs, so it should be probably a different thing. Okay, so error gen, let's create the C. Right. So let's do the following thing. And then the H, define, and then implementation. Right, so this is going to be a separate program that just generates the stuff. And we can actually take the adder.c and take the bits. Right, so we're going to take the bits. And how do we even generate this entire stuff? So this is how we generate the data. Yeah, that's the whole thing, actually, believe it or not. And what's funny is that we are doing separate matrices in here. We're doing separate matrices, which actually raises the question, maybe what we have to do instead, we have to sort of like put it into a single matrix. Right, put it into, yeah, okay. So we can just allocate a single matrix, which is going to be like a combination of these two. And then we can take like a sub-views of these matrices, bits plus 1. Right, so this one is essentially going to be like this. So ES, we start at essentially mat at T00, right, so that's what we start at. The amount of rows is the same as the amount of rows of the original one. The amount of columns, though, is 2 multiplied by bits, but the stride stays the same as from the original thing. So this is the sub matrix in here. So for the output, we do the following thing. I mean, what the hell is this actually? So ES, in terms of the row, it's still 0. In terms of the column, though, it's going to be offset by this thing. Right, it's going to be offset. The amount of rows is the same. The amount of columns is different. It's bits plus 1. And a stride is also the same because that's kind of the point. That's kind of the point of the stride. So, and that means I don't have to modify any of the code below, right? So this is done so I don't have to modify anything in here because I'm afraid to make a mistake, right? So they now are viewed, like this is a single matrix, but we take sub-matrices, like single views. And then we can quite easily just say, okay, save this entire stuff to, like, say, output T, right? We're saving not Ti or To, we're saving like the entire T, right? So, but to save this entire thing, we have to like open the stuff. Fopen adder, right? So what should I call it? Adder mat, right? So I think it makes sense to call it adder mat. And I'm gonna close this entire thing. And if out is equal to null, we can say something like fprintf error could not open file this. Right, and I have to provide std error exit 1, maybe just like return 1, return 0. Okay, and I suppose we need to have a file path, maybe out file path, const char this thing, I'm gonna put it in here, out file path, and then after that we can say printf generated as out file path. There we go. So we have a program that generates some data. So let's add it to the build script. So we're gonna have adder gen, and let's see if it's going to even compile. So I called it the get, not god damn it. My god. Okay, so let's recompile. Okay, so let's go through the compilation errors. So it doesn't have a string. Let's add the string .h in here. So what else do we want? So M is not structure or union. Member reference has a base size t. What are you talking about? Right, so ES, if I'm not mistaken, right, so if we take a look at the matrix, it's a pointer. And then I just do that. So that should result in a pointer. What? Am I being dumb? Reference base type size t. So maybe I don't understand how fwrite works. Right, here you're supposed to have a pointer. Right, so here's the pointer. By doing m.es plus n, I get a pointer because this is a pointer, this is size t. So if you add size t to pointer, you get a pointer. Oh, I see, because, all right, yeah. Why it wasn't complaining about, yeah, this is because it was shadowing. It's goddamn shadowing. All right, I see. I see. Shadowing, yeah. Shadow fact me yet again. Okay, so we are trying to actually write binary, and that should work. Implicit declaration of an end save. Really, that's actually really weird. Wait, excuse me? It's not an end save. Yeah, it's a mat save. Yeah, it's a mat save. All right, we're good. We're Gucci. With Maguchi. So yeah, all right, that's cool. And now one of the things I want to do, adder gen, and it generated adder matrix. Right. What is shadowing? It's when you define a variable, two different variables with the same name. Right. Essentially, you have a variable in one scope, and you have another variable with the same name but with a different type in a different scope. Yeah, maybe I can even do something like integer. because not everyone's familiar with size t, right? So what's going to happen in this specific case? Which x is going to be picked in this specific case? It's going to be x. So x, float x, shadowed the integer x. So that's what shadowing is referring to usually. Some languages allow that, some languages disallow that. Depending on the style and community and culture and religion, shadowing may be a good thing or it may be a bad thing, right? So it's kind of like a polarizing topic, if that makes any sense. Okay, so we created the matrix, right? So and this is how it looks like. So it kind of probably ruins the encoding. So yeah, here's the magic, and then we have the rest of the stuff. So we can take a look at in hex mode, right? And yeah, so we have some data in here. We do have some data in here. So let's actually close this entire thing, and now we should implement a thing that loads up the matrix from here, right? So essentially, we need to implement a symmetrical function to nn save, and it's going to be nn load. So since we know that the magic is essentially 8 bytes, I can actually save this entire magic in here, right? So we're loading. So loading is probably going to allocate some memory, so maybe we just have to do it like that, right? So mat load, we're going to return the matrix. This is a mat load, there we go. All right, so we're going to f-read magic, size of magic 1, and this is going to be in, right? So we just read the magic, and we have to confirm that magic is equal to that thing somehow, right? So we can take a look at how it is represented within the entire thing. So I need to open the adder mat, so I can take a look at the hexel, I suppose, right? So what is it? nn.h and xxd. What is it called? Adder dot mat, right? And let's actually do the head, right? So this is basically how it looks like, and what we can do, I do believe so, is copy this here and just say, okay, we expect this magic to be equal to that. I think that's how it's going to work, hopefully, but maybe because of the because of the little endian and some other shit, it could be actually written in a reversed order, right? So it's probably gonna, it's probably gonna fail. So that means we'll have to reverse the bytes or something like that. Though quite often people use this kind of stuff to determine what platform they're in, whether it's a little endian platform or big endian platform and stuff like that. So in any case, I'm gonna just keep it like that, and if it fails, we can fix that. Doesn't really matter. So the next thing we need to do, we need to have rows and columns, right? So we need to have rows and columns. So let's read rows, size of rows, 1 in, and the columns. And one of the things we want to do, we want to allocate the matrix with these rows and columns. Once we allocated that, we just want to keep reading this entire stuff, right? So we're gonna have size tn, f read, so es, size of es, and what we want to read, rows and columns, right? So this is gonna be rows and columns in. And while n is less than rows and columns, and there is no error while reading over that, we want to repeat this entire stuff, but actually plus n minus n, right? So let me double check mat save, plus n minus n. Okay, so just double check that everything is correct, and n plus k. There we go. So that should read this entire thing. So, okay. So the thing we want to do in here, right? The thing we want to do in here now is go to the gym, right? And read the whole thing, right? We want to read the whole thing. Interestingly, so in case of, you know what? That is very interesting. When we reading this entire thing, we don't really need to use an unload. We could have just like loaded the whole matrix into the memory and then just use that, right? So then we could construct the matrix structure and just point its ES at the correct place and set rows and columns. That's one of the things we could have done, right? So who said we can't do that? I think we can. So yeah, that's actually probably even better, if you know what I mean. Right? It's actually probably even better. But I probably want to do that a little bit later. So I think I want to make a small break because I'm already streaming for 2 hours, right? So I would like to make another cup of tea, right? And after the cup of tea, we're going to continue doing this entire stuff. Okay, let's continue. So let's go ahead and maybe open some stuff in here. So honestly, I would like to actually accept the arguments through the command line, right? So that would kind of make sense. Right, so if argc, so usually the way I do that, I use the shift pattern, right? So can I copy paste the shifts from somewhere? Do I have shift in here? No, I don't. So the idea is essentially that I have shift function in here, which accepts the pointer to argc and triple pointer to argv. How about that? Isn't it poggers? I think it's pretty poggers. So so we usually call it args shift, right? So this is args shift. One of the things we want to do, we want to assert in here that argc is greater than 0, right? So then we can do essentially argc minus, and one of the things we have to do, we have to come up with the result, right? So, and the result is essentially argv, right? But it has to be like a, yeah, we need to do the double dereferencing to actually get to the thing. And maybe here I'm gonna do something like this. And in here, I just dereference this specific thing. I need a +1 and get to the next sort of pointer, and this is going to be the result. So here I'm going to have a program, right? So this is the program, args. Did I call it args shift or just shift? Okay, so I called it args shift in this specific case. So provide it like that, and there we go. So after that, I can check if argc is greater than 0, right? If it's actually less or equal than 0, that means not enough arguments were provided, and we can actually complain about that. Std error, right? So error, no architecture file was provided. So first one is going to be architecture file. Right, and we're going to return 1. So after that, we're going to do arch file path, and this is going to be just args shift argc argv. So we're sort of like a popping out the stuff, right? If after that argc is less again, that means no data file was provided, right? So no data file was provided. So, and in here we just do actually, yeah, let's call it data. So this is a data file path. So, and in here, instead of this thing, we're just using arch file path. And I suppose in case of an error, this entire thing would return boolean, null, I mean, sorry. And in that case, like the function already logs that it couldn't load the file. So we don't really have to do anything. We can just like, you know, put 1 in here and don't worry about anything. So then we're parsing architecture. So everything seems to be fine. And the next thing we need to do I suppose, let me actually comment out this entire part for now. We want to load the matrix, right? So we want to do load, not and then matrix. But we have to provide the in, right? So we have to provide the in, and that would give us the training matrix. So in is essentially fopen and is going to be data file path, read in binary. If in is equal to null, we can say that we couldn't read the file. Alright, error, could not read file, this data file path, like so, and we're gonna just return with 1. After that, we're gonna close this entire thing. And one of the things I want to do, I want to just print the matrix that we managed to read from the file. Hopefully, we'll see. So one of the things we probably also want to do, I want to print the usage, right? Just to tell the user how you're supposed to use this entire thing, right? So it's going to be the usage. This is the program, right? Then you have to provide the, you know, model arc, and then model mat, right, which is the matrix. Right, and we're going to do it like that. We're going to say it twice in here. So now let's try to, is this a gym? Yeah, it is a gym, so it is correct thing. So let's try to build the entire thing. So yeah, we have to do source opt Raylib environment, and there we go. So what is it complaining about? It complains about magic expected semicolon. What the fuck is this error? Are you freaking serious? Like, is that because uint64 is undefined? What the fuck is the, like, I mean, okay, if the reason that like, okay, I can just try. This is the most unreasonable error message I've ever seen in my entire fucking life. Is that the reason? That was fucking reason. It had nothing to do with semicolons. Holy shit. Can you restructure your parsing so you don't have to say such thing? Like, what? Maybe this is a problem with C. Like, it's just like, this is so bad. Like, it's not helpful. When your error message is unhelpful, it's a bug. This is straight up unhelpful. Well, I mean, at least it wasn't that bad that I couldn't figure out what exactly happening, but it's bad. Like, these kind of error messages are bad. Straight up. Because, like, semicolon, like, what the fuck are you even talking about? It has nothing to do with that. At least reorder your errors or just do something. Oh my god. I don't know why things like that piss me off, but it's just like, I don't know. I swear to God. Anyways, I'm sorry. Gym. No architecture file was provided. Okay, so let's provide the architecture for the header. Alright, no data file. Do we have an header mat? There we go. So, and the magic is not equal to that because it has to be, I suppose, reversed, right? So let me try to do the following thing. I wonder if there is like an easy way to reverse this thing, like not manually. So can I do reverse region? No, it didn't really do that. One of the things I can do, I can probably split this into new lines. All right. And then just reverse and then concatenate everything back. Can your Vim do that? Can your Vim do that? It cannot do shit. It can't. I'm sorry. And insert, and there we go. So I suppose that's what it has to be. Let me see. don't know what the compiler is supposed to do in that case. If the identifier is declared, the terminating, if the, what is it supposed to say? It's supposed to say identifier is not declared. That's it. Why? It feels like it resolves the type defs at parsing time. That's what it feels like. And why do you resolve the aliases type defs at the parsing time? Is that because the language forces you? That means the language is shit, which actually confirms my hypothesis that C is shit. So yeah, why are we still using this language in 2023? Why are we still forced to use this language in 2023? Why there is no good alternatives to C? No, Rust and Zig are not alternatives to C. Anyway. So. Okay, so let's try to. Okay, why did it remove this kind of thing? Raylib environment. Here's the matrix. Here's the training data, chat. This is the training data we recovered from a file. Isn't that poogers, my dudes? Isn't that poogers? I think it's pretty freaking poogers. So this is basically what we had to do. Right. The NDNS fucked me in the ass yet again. The NDNS. Okay. But here is the thing about T. So we still need to split it into TI and TO, right? So we still have to do that. So let's construct this thing like so. It's kind of similar, right? So in terms of the rows, it's going to be the same amount of rows as the original thing. In terms of the columns, actually, it's going to be rather interesting. So essentially, we're going to have an assertion. We're going to have an assertion that amount of columns of this thing, amount of columns is this thing, is actually equal to the architecture data 0 plus architecture data last one. Right. So, yeah, because the first n columns is the inputs, and the second n, like m columns, is the outputs, and n is equal to the amount of inputs and the amount of outputs. Right, so which kind of implies that we also expect n count to be at least greater than 0. So, and in that case, maybe it has to be even greater than 1, because you need to have inputs and outputs. So, but I'm not 100% sure about that specific case. So that actually boils down to, can we have NN with just input? Because I'm not quite sure, like, what's the implication of this stuff? What's the implication of this stuff? So, yeah. Anyways, so here, it would be nice to have like a separate stuff, right? Inputs. We can call it ins size, right? So it's going to be size t, ins size, and this is going to be outs size, which is arch count -1, outs size. So in terms of columns, columns is going to be ins size, stride is going to be the same as the stride, original stride, and ES is basically matrix at 0, 0, T, that's just a point. There we go. So the outputs, alright, so the rows is the same, the rows is the amount of samples, the columns is out SZ, stride is the same, stride is the same, and then we can do mat at T, and so this is the offset is ins size. There we go. So, and let's actually see if we manage to separate these things correctly. So I'm going to print TI, and print to O. Right, so let's see. So did we manage to separate this correctly? It doesn't work. Is it because it's items? Yeah, it's called items, I see. Alright, so semicolon. Excuse me. What else? Yeah. Okay, so it seems to be, yeah, so this is correct separation. Right, this is actually pretty cool. Alright, so that means we have everything, so we literally have everything, and we're ready to go. So, let's start the window, right? Let's start the window. And let's continue copying this stuff from here. Error.c. Alright, so we just do the back propagation, right? But that requires NN and G, right? So let's actually construct those things, right? So we're going to be constructing those things like so. So we also have a learning rate, which is usually 1. I think 1 is kind of dangerous thing to have, but that's totally fine. That is totally fine. All right. And I guess that's it. Right. So let's try to compile this entire thing. I'm not gonna run the gym for now, right? Because it will start the UI and stuff. So let's go to the compilation errors. So arch, yeah, so we already have arch. Arch is supposed to be items and arch count, right? So that's what it's supposed to be. Anything else? What other compilation errors you want to throw at us? It's a count. Come on. So we don't have an Raylib rendering, so because we need to copy paste it from here. Right, so let's post it somewhere here. All right. All right. Just to make sure, I checked your dot files and it's really CPU temperature. Wow! Finally, somebody figured out that you can do that. You're probably the first person who managed to do that, or at least you're the first person who claimed that you managed to do that. It's just like people keep asking me, what all of that stuff in your bar, but you can literally look it up. It's just like all online. It's just like, and it's all public. All public. You can just look it up and see it for yourself. Yes, thank you so much. I really appreciate you. All right, unironically, actually, unironically. All right. So we finally managed to create a gym. Right, so it doesn't really have a configuration about like how many iterations you want to have and stuff like that. But that's maybe fine. Like a lot of the stuff, maybe in the future we can move to architecture file or to config file or something like that. The thing I don't like about the data file is that you need a separate program to generate it. Right, I mean that maybe that's just fine. Right, maybe that's just fine. Okay, so let's actually try to run gym and see if it actually performs well, right? If it's actually doing anything. Yeah, is it learning? Well, the cost function is actually decreasing, right? At least. So yeah, it's slowly emerging. I really like how it's just like they start to light up when you're training this. I think this is so cool. So by the way, another interesting thing I wanted to do, believe it or not, is change the thickness of the lines depending on their value. That's one thing I would like to do. Yo, let's quickly try to do that. Right, so I'm gonna just take a look at and then render Raylib. Right, and so essentially where do we draw the lines? So here are the lines. So if I take a look at Raylib, draw line, is there anything with thickness? Oh, okay, so yeah, okay, so draw line X, so extended, and it allows you to draw with the thickness. Okay, that's pretty cool. So I suppose, so the thickness comes before the color, so this is gonna be the thick. So is it float? It is float, perfect. So we can do float thick, and we're gonna have it as 1. So this one is gonna be EX. So interestingly, so here is the sigmoid value. So we take the value of the weight and we squash it with the sigmoid, right? So we can basically use the same value. We know that it's going to be from 0 to 1, right? It's going to be from 0 to 1, so that means we can have the thickness from 0 to 10 and just multiply it by the value. And that will work automatically, I think. Right, so this one is actually, has to be here. There we go. So that should work, I think. So let's give it a try. I think it's gonna be pretty cool. It doesn't work. So too many things. Alright. Draw at Bezier curve. Look at that. Oh, fucking. Really? You're gonna have a draw line with separate components, but draw line X with vector 2 and vector. Okay, sure. Can I construct vector? Probably, I don't know. Vector 2. Start. Can I just do CX1, CX, CY1, and then just end. This one 2. It's gonna align. Literally unusable. Literally unusable. I'm joking, by the way. I think they're a little bit too thick. Okay. Are they gonna become thinner? They kind of become thinner. Yeah, I feel like they're a little bit too thick. Though they're kind of fine. So we can see how they're sort of like, so what are the strongest things in here? That's kind of cool. We can take a look at the, okay, so I think 10 is too much. Right, I think 10 is too much. So what about 5? Also, I want to be able to print the epoch. Right, so let's do epoch. So this is I. Alright, so maybe SQR the value. Maybe, I don't know. One of the things I want to try is Zor. I think Zor is going to be kind of interesting. Look at how thin it becomes. Like, it became too thin. Yeah, it became almost 0. Right, it's just like, this connection almost disappeared. Yeah. Basically, which is probably not particularly good representation of this entire stuff. But maybe it is. So, yeah, that's why, like, people... yeah, I know that this is wrong. I know that this is wrong. That's why I'm actually double thinking whether to include that or not. But that's interesting nonetheless. It's kind of interesting. That looks cool at least, and that's what gives the views, am I right? So who cares about correctness? Anyway, so let me actually get rid of the thickness, right? So because I don't think it's particularly good idea. Right, so, but I'm gonna keep the possibility to do the thickness anyway. Is an N calculation stuck to Raylib max FPS? Yes. That's why I was thinking about doing that in a separate thread at the beginning of the stream. But why I don't do that in a separate thread? Because it's unfinished. Zoyzin, why your unfinished code is unfinished? Ah. Okay. All right. So let me continue. Unfinished code is unfinished. So what I want you to do, I forgot what I want to do. I want you to do XOR, right? So I'll do XOR arc. So we have two inputs, 2 and 1, right? But for that, we need to generate this kind of thing. So yeah, this is the very much inconvenient thing. Right. It will be kind of better. So I suppose I have a feeling, chat. I have a strong feeling that the data has to be text format. I have a feeling the data has to be text format. Because this is like, I literally don't want to do that. The thing I want to do with the XOR matrix is just say, okay, we're gonna have 4 of the 4 rows, and how many columns are we gonna have? We have 2 inputs and 1 and 3 of these things, and then I want to say, okay, 0 0 0 1 1 1 1 and 1 0, and that's it. I don't want to be dealing with the rest of this stuff. I don't know if you noticed, but your unfinished code isn't finished yet. How can you even stream this? Yeah, that's a good question. Thank you. So I feel like this is what I want to do, if you know what I mean. Right. So I want to do that because it makes it easier to generate like a smaller data, right? Just generate a smaller data. So I feel like binary format, it might be useful for like storage purposes, if you know what I mean. It could be useful for storage purposes, but for other purposes, yeah, we should have 2 kinds of formats. We definitely should have 2 kinds of format, like a binary one and a text one. Right, so that's the thing that we definitely have to have. Right, so and for the XOR, maybe I'm gonna just like quickly generate XOR. I think that's one thing I can do. Yeah, let's go ahead and do that. XOR gen C. I'm gonna define and then implementation, and then I'm gonna just include nn.h. So I'm gonna just do it like that. So mat alloc rows 4 and columns 3. Right, so and one of the things we can do in here is essentially mat at t 0. We can probably do it like so. Mat size t 2. T it's more of a like 2 plus j, I would say. That's the row we have in here, and the column 0 has to be equal to I, so we can say that this is a sample, or maybe we can even call it a row. Maybe we can even call it a row. Right, so this is I, this is j, and this is I XOR j. After that, let's actually print the results. So this is a matrix print. Build.sh. Okay. It's like what versus wasm. Yeah, probably, because one is for machines, another one for humans. Okay, so this is what we managed to generate. Kind of, what if we could just parse this entire thing? Yeah, what if the format was literally just like this? Right, you could just dump that and just read that. because it also stores the information about the dimensions and stuff like that, but the parsing that is kind of an S, so I'm not sure. Anyway, so what we want to do, right? We want to actually do something like out fopen, so out file path, write in binary, const char out file path is going to be equal to what? Zor matrix, right? So, and if out is equal to null, printf std error could not open file s out file path return 1, and then save out t, and then we just close out printf generated as out file path. Okay, let's try to generate some shite and then save. Keep forgetting, it's just reflexes. Okay, root mat. Okay, so looks good to me. All right, so do we have a Zor arc? So this is Zor arc and Zor mat. So that means now we can take a gem and provide Zor architecture and Zor matrix and just see how it's going to train this entire thing. There we go. So it is slowly training this entire stuff. It's kind of interesting how this entire thing becomes negative, this thing becomes negative, this is negative, but those things are positive. And it's just like, yeah. That's pretty cool. So that's basically the thing. So for the thickness, I think we could make it a tiny bit thicker, right? Maybe even 3, right? So we could at least see, right, this kind of stuff. So it's gonna be gem, Zor, what is that? Architecture, Zor, matrix. There we go. Yeah, so I think the lines are a little bit easier to see now on the screen. I wonder if it always converges to like these things to be negative, right? Yeah, and it could become really, really strong over time. Right, that's kind of cool. That is kind of poggers, not gonna lie. Looks the same. Yeah, it basically converges to the same thing. Right, I suppose that's what it does. It converges to the same thing. Right, because maybe that's the optimal solution anyway, right? So it just will converge to the same thing. In case of an adder, right, in case of an adder, we should probably not rebuild everything. I don't know why I'm doing that. But, yeah. Yeah, I should have actually made the weights thicker a little bit, starting from the start, because it just looks better. Yeah. Man, that's so cool. It's actually so freaking cool. I love it. So another cool thing would be to plot the cost function as well. So we got some bits from Nitrix Dev. Thank you so much for 100 bits with the message. I bought programming socks and now 2x more productive. Thanks, so you're welcome. I actually don't have programming socks, believe it or not. That was a joke. In that clip, I was just like joking. So I don't really have programming socks, but I do still recommend to buy them. I still recommend buying them. Man, this is so awesome. And it becomes brighter, so I suppose the disabled things are basically the gray one because they're closer to 0, right? And it stopped. So okay, it finished rendering essentially, right? So I mean training. So this is basically the final result. Femboy outfit when it stops being illegal in my country, or when I actually get out of my country. I don't know. So okay, go. So that's actually pretty cool. And then maybe you could have like a button save this neural network, and it will just dump it in a binary or textual format. It depends on like which one you want to use. Maybe there's some sort of like a standard formats. Is there any standardized way of storing this kind of stuff? Maybe we could just support the standard things so we can just load them up. Yeah, that's a very interesting question. Right, why invented our own formats if we could just like use existing ones? And that will allow our library to actually maybe even evaluate existing models. Why not? Sounds like a good idea. Right, I don't know, but I'll have to think about that. Right. So one thing I definitely wanted to have, right? One thing I definitely want to have is plotting the cost function as it learns. You know what I mean? I think that's quite important, but we need to have some space for that, right? So because this entire thing is just like taken over by, you know, this entire stuff, so which is not particularly convenient in my opinion. So what I want to do, I want to customize and then render Raylib, right? And what I want to do in here essentially is specify at least like width and height. Right, so I want to be able to specify the region within which it will render that specific neural network. Right, so here I want to pass a rectangle, and it will just draw that thing within that rectangle. So a rectangle is usually like X and Y, right? X and Y, but for now I'm gonna just start with just width and height, right? So this is gonna be width and height. So Google search showed this an open source format for neural networks. Okay, so let me check it out. Let me try to open it up. Open neural network. Okay, so the fact that it's open doesn't really mean anything. Does anybody use it? So there is a lot of open formats that nobody uses, right? So is it actually used? So that's the real question. Okay, so there's a bunch of logos of companies. Like, I don't know, I can imagine just a website for a library that explains the library, and then it says, and here is a bunch of companies, and it just lists a bunch of companies, but it never says that the companies actually use your library. It just says, here's a bunch of companies. It's just like a random companies we found in the internet. Like, they have nothing to do with our library, but here's a bunch. Because, yeah. Because nobody's gonna read that. They will see, oh, this is how many companies use that, but they will never read the title that here's a bunch of libraries or companies. You know what I mean? Because, I mean, wait a second. Yeah, our archive community. Yeah, nowhere on this page they say that this company actually used this format. Just think about that. Nowhere on this page they say that this company used this format. So this could be just a list of random logos of random companies. Communities. So again, I know nothing about this format, by the way. I'm not trashing in it. I'm just like saying I'm not even an AI person. So the thing I'm interested in is it used? I suppose it is used actually. Maybe in CSS selector. Yeah, maybe it's set in CSS selector. All right, but I mean something exists. So I'm gonna give the link to that in the description. Right. So okay. They have a pretty cool design, and they have a pretty cool domain. So that means they have money. Where did they get all of that money from? I suppose from the sponsors. So that means that somebody probably uses that. So that's my conclusion, basically. So I'll look into that after this stream. All right, so let's actually try to control the width and height of the region that we're rendering. Right, so let's quickly replace image width with W. There we go. And then image height with H. I'm not sure if that's a good idea, but we'll see. All right, so if I try to recompile, it will fail. By the way, I think I don't need to compile these things, right? So because we already generated some data. So in here we have to specify, okay, so I can say image width and image height. Right. Image width and image height. Pores. And okay, so that seems to be working. What if I divide it by half? Right, what if I divide it by half? So what's gonna happen? Okay, so that actually rendered the entire thing in a smaller region, which is precisely what I wanted. But that didn't change the sizes of the neurons. And this is because the size of the neurons don't depend on the size of the region they're rendered in. So what I'm thinking is that we should make them dependent, right? So we should make them dependent. So what is the size of the neuron? So we draw the circle. Okay, so there's a neuron radius. So let's find this specific parameter. So it's 25. Let's make it dependent on the on this thing, on the height, for instance, right? So what is the height? Right, so what is the height? The height was 9 multiplied by 80, right? So it was 25, right? So we have this parameter, and this is 0, 0, 3, maybe even 4. So essentially, what we can say, neuron radius, we can make it float, and I suppose it's going to be just image height 004 or something like that. Right, so let's actually use the original size in here. Right, let's try to use the original size. And let me see. Okay, so that looks reasonable. Now, if I divide it by 2, right, if I divide it by 2, is it going to be smaller? No, it is not smaller. What the fuck? Is that because I'm a stupid dum-dum? Yes, I am, because you're supposed to use H. We've got a sub from my favorite person on planet Earth. Leonte, thank you so much for tier 2 subscription. Thank you. With the message, it's so cool. It's so cool indeed. By the way, aren't you the author of Focus, right? So, Focus editor. I think you are the author. Actually, there's a lot of contributors, but you seem to be the, you know, the main contributor to that thing. Focus editor Jai. I don't remember how to find that. Boot LS, thank you so much for Twitch Prime subscription. Thank you. So it's actually really cool editor. And I'm a contributor. I did the Linux port. Okay. In any case, you seem to be like the person who contributed the most. So if you guys are interested in Jai and what people actually do with Jai, check out the Focus. It's an editor that is written completely in Jai, and it's actually super cool. So it doesn't work for me. Actually, you know what? For me, it crashes. And you know what it crashes with? It crashes with SIG-IL. And it crashes on mu-hash in the places where it uses some SSE instructions or something like that. So it feels like it uses some instructions that my CPU doesn't support, and I didn't look into that problem. I just tried to run it, and this is what I saw. But that's kind of weird, right? So this is just something like I didn't report any bug because I was not sure if that's like my problem or something else. Right, so a little bit later, if I remember, I will try to investigate and see what's up with that. But that's rather interesting. So in any case, I'm gonna, because it's actually super cool. I really want to try it out. I'm gonna give the thing in the description as well. Text editor, engine. Right, and some AI format. What signal is used for? It's basically a signal when that is sent when you try to execute a legal instruction, right? So it could be hardware thing, or it could be something else. It's not necessarily like a known instruction per se. It could be some sort of a bug that made the instruction pointer jump, for instance, in the middle of an instruction, right? So, and that resulted in like just combination of bytes that is not a correct instruction. Right. It could be either like a usage of actually instruction set that is not supported by my hardware. It could be my hardware problem, or it could be something within the application that made it jump to a wrong place or something like that. It depends. If you build it locally, you get the same crash. Actually, building locally is the only thing I tried. I didn't try the official executable or anything like that. Right. So yeah, I can maybe show you. Right. So let's actually quickly go here. So I think I have an old GI right now. So I didn't test on the one that actually got released recently. So we'll see. So let me take a look at the version. So here is the version. Yeah, so yeah, it's far from the latest one, unfortunately. Okay, so do we have first? Okay, so I'm gonna just like use first and see how it goes. Set undeclared identifier. Yeah, okay, so my GI is too old. All right. I'll check it out later, and if I find anything worth reporting, I will report a bug about that. Right, so yeah, my GI is too old. So it's already fixed and nightly, by the way. Okay, so let's actually continue. What I was doing, right, I forgot what I wanted. Yeah, okay. So let's actually see now if it, yeah, okay. So as you can see, neurons are smaller now, which is cool, which is nice. So, but the width of the thing, right? The width of the thing, of the weight, still doesn't depend on the height. So this is something that we'll probably also have to do. All right. So the width, if I'm not mistaken, right? So thickness is actually 3. Right. If we divide 3 by what was that? I already forgot. Yeah. So 980. Right. So that and 3. Okay, so this is 004. So thick, we can do H 004. So that's basically what we're doing here. 004. Yeah, it's kind of the same, right? So 004 and 004. Huh. That's an interesting coincidence, I think. That's a very interesting coincidence. All right, so that looks better. Isn't that cool? Right, so now I can just like change the sizes in here, right? I can divide it by, I can make it even smaller, I think. I can make it even smaller. So at some point, I think the lines may become invisible, right? And then, for instance, maybe I can multiply this entire thing by 2, which will actually go outside of the window, but it's going to be bigger. So we can now control the size of the thing that we can render. Yeah, so that's actually pretty cool. All right. And the entire like width and sizes are very much dependent on the height. So that's how we operate. But that's not enough, right? That's not enough. Another thing I want to be able to do is to specify the offset for the entire thing, right? So right now, the offset is at 0. Okay, so this is actually pretty cool. So we control the offset with NNX and NNY, which makes it relatively easy to just do something like this, right, with X and Y. So let's actually rename these things to maybe RX, RY, meaning rectangle or region. So, and then we can say, okay, offset that by r, x or y, right? So it's going to be x or y, something like this. Okay, so let's go through the compilation errors. There will be some compilation errors, right, that we need to fix. So this is another thing. What else? So unused parameters, so that's fine. So, and then here, okay, so here we have to specify 0 for now, at least. So what I want to do, right, what I want to do, I want to center it somehow, right? So let's say that the actual width is going to be image width divided by 2, and the actual height is going to be image height divided by 2 as well. The actual x in that case is going to be image width divided by 2 minus rw divided by 2, and y. So we sort of like a centering this entire thing, which makes it super easy to just do rx, ry, rw, rh. There we go. And is it going to center this entire thing? We'll see, we'll see. Yeah, it's centered. So that means we can just pick whatever region we want, and we can say render the entire neural network within that region. So which makes it super easy to just relocate it to different stuff and allocate some space, for instance, for the plotting of the cost function. Isn't that cool? Right? I think that's pretty cool. Right, for instance, I can say that I want this entire thing to start at 0, right? So that will align this entire thing to the left. And it's aligned to the left, essentially, right? So, and we can plot the cost function somewhere here on the right. Or maybe we can align it towards the right, because maybe I want to have the plot function there. So let me see how we can do that. It's essentially our this minus actually image width, right? So it's image width minus rw, and that will align it to the right, right? Very cool. Yeah, I know. Thank you. Right. So that's pretty porous. We can actually do another cool thing. We can say that the height is actually going to be the whole height, right? So that will stretch the neural network up, right? Because it's now like half of a height. So we can control this kind of thing, and let's see how it's going to look like. It's going to look differently, and we can't see shit in this mist, which is kind of surprising. Yeah, because this is not what we're supposed to be doing. What we were supposed to be doing is setting the height like this in here. Okay, so that makes sense. Right, there we go. So it's just stretch it like that, which doesn't really look that great, in my opinion, if you ask me. But that's one way to do that, right? Anyway, so I suppose I could just make this thing. I think half was alright. I think half was alright. Just to be able to see like how it goes. Maybe not even half, maybe 2/3. How about 2/3? Right, so multiply by 2, but divide by 3. 2/3. Could be like a cool middle ground. Yeah, that's a good middle ground in my opinion, I think. It's pretty progress. Pretty progress indeed. All right, so, and where are we going to render the cost function? Right, so with the cost function, what we need to do, right? So we need to have, we need to store the samples of the cost function somewhere, right? So we need to periodically just check what's the current cost, and we need to add it to some sort of an array, right? So maybe I'm going to introduce like a dynamic array. It's definitely going to be a dynamic array, right? So cost plot, right? And we're going to have items which are floats, right? So here we're going to have a count, and here we're going to have a capacity, right? And essentially, periodically, if I is divided by 10 equal to 0, instead of printing that cost, we're going to be appending that cost to the plot, right? So we can do di append, maybe we're going to have like a plot, and we just literally add this entire thing to the plot, and that's it. right? And then when we're rendering this entire stuff, we're gonna be taking that plot and we're gonna be just like literally rendering it. That's it basically. Right? We'll see how it goes. We'll see how it goes. Okay, so here is an interesting thing. So an render Raylib, it cleans the entire background, but since it's just a small sort of like a sub widget, I think it should not be responsible for cleaning the entire background. It should be done outside somewhere here, right? Like so. Yeah, so it's probably want to do something like this. There we go. So we begin rendering, clean the background, and here we clean this entire thing. So, and probably I want to do something like a cost, like render, maybe plot cost, right? And then here I could specify the plot, right? And I probably need to put it somewhere here, right? Cost, plot, 0, right? So it's going to be like that. And here we'll have to specify the region within which we want to render this entire thing. Right, so I suppose we can do a similar thing. Right, we can do a similar thing. But we'll need to reinitialize this stuff. Right, so what I'm thinking is that in terms of width, it's going to be half of the width. In terms of height, let's keep the same height, but the difference here is that it's going to be aligned from the left, right? So on the left we're going to have a cost function, on the right we're going to have the neural network. So maybe it would be even better to actually swap these things around, and to be able to easily swap them around, I think I'm going to do something like this: int rw rh rx ry. There we go. So that way I have these sort of components, right, that I can like swap around and stuff like that and everything. Okay, so let's implement a plot cost, right? So let's see where we can put this entire stuff. So this is going to be just cost plot, and this is going to be just a bunch of integers. So for now, just to see that it's working, right, I'm gonna just draw a rectangle, right, and draw like a red rectangle just to see where it's gonna be located. Draw rectangle, so it accepts everything I want to see. Y or H, red, and let's try to run this entire thing. So plot unused variable background color. Okay, so background color is not particularly neat. Right, because we moved this stuff outside, so let's put it in here. Plot is unused. Okay, so that's cool. So this is where we're gonna have a plot, right? So this is where we have the neural network. So, and the left widget, this is where we're gonna have all of that. So the padding comes from the fact that we're taking 2/3 of the height, I think. Is this 2/3? Does it look like 2/3? I guess it is, right? So if you add up this padding and this padding, it actually adds up to 1/3 of the height of the screen. So that kind of makes sense, right? Who needs CSS, chat? Right? Who needs CSS? Like, it's actually way easier to do whatever you want without CSS because it doesn't stay on your way. Am I the only one? Am I crazy, by the way? I find it easier to come up with the very flexible layouts if I don't have this CSS craziness and I'm just allowed to place things like in absolute values. Right, I'm not alone. Okay, that's cool. Right, if you just have variables and you place all of the elements in absolute terms, you can quite easily come up with very flexible layouts. Like, it's just like, yeah. Centering is just, you take half of the screen, half of the size of the element, and you subtract one thing from another, and magically it's centered. Without any of this freaking bullshit with centered left, right, like, why? You take one half and subtract another half. It's a simple arithmetical operations. Anyone can do that, even designers. I mean, I've met actually very smart designers that know like geometry and mathematics quite well. So just, I'm just saying. Still use tables, and you can also simulate tables. Sometimes I feel maybe it's because I'm a C programmer, and it's just like if you if you know how to use the hammer, right? Everything looks like a nail. I don't know. But I find like defining things like that easier. Beat. I would accept this bullshit called CSS, but nothing ever worked. Yeah, it's really difficult to do anything in CSS. Anyways, alright, so how are we gonna be plotting this entire stuff? So one of the things we can do, we can find the maximum, right? So because we want to be able to fit this entire thing somewhere, right? Like in width and height. So let's find the maximum, yeah, the maximum value, like cost plot max. And it's going to be float, cost plot float max. So, and it has to be the minimum value, right? The minimum. Is there something FLT min, right? So that's probably what we want to do. So for CSS is difficult even for the browser. Yeah, I can imagine that actually. I see what you're talking about. So if max is less than plot items I, what we do is just say, okay, it's equal to this thing now. And we just have to return max. There you go. So, okay, we need to have the maximum value, cost plot max. It's kind of meh to do that on each plot cost, but we're not trying to write the most optimal code ever, right? So we don't really care that much, in my opinion. All right, and essentially now, do we also want to have like a minimum? I think minimum is also very important, right? So we can do that in one go. Let's do min max. All right, so it's going to be min. This is going to be max. And right, so let's do min FLT max, max FLT min. Right, and maybe, just maybe, I'm going to do the following thing. Min, if it's greater, we're going to set it. And here we don't have to return anything. So it means here, I'm going to have min max and then cost plot. Min max plot min max. Who needs multiple return values? Am I right? All right. So min and max. So that means we can already do quite a cool shite. And it's essentially, yeah, let's iterate through all of these things, right? So iterate through all of the samples. Plot count. Right, so plot I. By the way, I just want to like compile this entire thing. Yeah, FLT max and FLT min are not a thing, but I don't remember. Probably I have to include limits, if I'm not mistaken. C float. Oh, there is also float. I'll see. Okay. Float. Which one? Yeah, boy. Yeah, boy. Okay, that's cool. Cost plots. Okay. All right. Pretty epic. Not gonna lie. Not gonna lie. So 0 less than plot count count plus I. So okay, in terms of y, it's rather easy to determine how it's going to look like, right? So essentially we have plot items, so this is I, and we kind of subtract the minimum out of that, and it gives us this sort of value, right? And what we need to do, we need to divide it by maximum minus the minimum, right, by the distance. And what we get is actually a value from 0 to 1, right? It's a value from 0 to 1. So if we multiply it by the height, we get the value somewhere on the height of the widget, right? But it's not going to be offset properly. So another thing we'll have to do ry plus, and that gives us y precisely on the widget itself. So the only thing we need to do, we need to figure out x. So the bigger the I, the bigger the I, the bigger the x. The bigger the I, the bigger the x, the bigger the I, the bigger the x. So that means it depends on I. Right, what we can do, we can take the width, and I think it has to be converted to float, and we want to divide it by the plot count. Right, and then multiply by I. That's freaking it. So the next thing we can then try to do, once we've got x and y, we can just plot the points, right? So it would be nice to connect them with lines, but I'm gonna just draw circles on, you know, on the place of them. Right, how are we gonna draw the circle? So I remember. So it's a center, so this is gonna be x and y. And the radius is going to be dependent on RH. We already learned that. And let's actually make it as small as the width of the weight, right? So 004 essentially. And the color, let's actually pick color red, because why not? So I think red is fine. And that should give us the plot cost, I suppose. Isn't that cool? I think that's pretty cool. So, something dangerous. Our X is not used. Yeah, thank you. That's very important. Okay. Are we good? Are we Gucci? Are we Tamaguchi? Huh. That's actually... Alright. The question is, why is it growing? Huh. What I'm thinking, chat, is that the height... Wait... Is it... Are the Y's inverted? Wait a second. I need to check that, chat. This is very important. Draw circle. Is this one of these libraries that put 0 at left bottom? Right. So 0, 0, 100, red. Show me what you've got. No, okay. What's up with that then? So am I an idiot? I think I'm an idiot. Because initially, why? So initially it has to be rather big, isn't it? I'm pretty sure. Okay, so let's maybe connect that with lines, right? So let's connect that with lines and see how is it going. Draw line. So draw line. So we're gonna put it in here, but that only makes sense actually if y if y plus 1 is less. So here is the thing. I suppose we need to do something like -1 to make sure, or maybe even I plus 1, right? Because we're talking about like unsigned integers and stuff like that. Right, so this is going to be that. This is going to be Emacs 2. This one is going to be +1, and this one is going to be +1. So x1, y1, x2, y2. And the color is red. Maybe we can even do something like this. The thickness is RH multiplied by 004, like so. Semicolon. What else do you want? Expected for draw X line. Ah, this freaking... Okay. So vector 2. Maybe there's some constructors for this kind of things. I don't know. Yeah, I need to, yeah, I can see why I need to invert y now. Yeah. Okay, so that makes sense actually. So let's go ahead and try to invert y. So, but we can invert actually the 1, right? So this value is from 0 to 1, right? So we can just do something like this. Easy peasy lemon squeezy. Right, so that should actually work now, I suppose. Yo. It would be kind of nice to also provide some sort of a reference point. I don't know. But yeah, because it's not clear where is the, yeah. It's kind of cool that it just like jumps, right? So we also take the steps of like 10, but maybe this is not what we should do, right? What if we like take each individual thing in here? Is it gonna be faster? Yo. It's kind of interesting how it learns in jumps. You know what I mean? It learns in these jumps. Right. It's sort of like a energy levels. Right. Sort of like energy levels. It's actually kind of cool. Right. And it doesn't really improve that much overall anymore. Right. Okay. That's cool. So let me see. So maybe I could make it a bit thicker, right? This entire thing. Cost plot plot. So in terms of thickness, we can say, so the bigger the value in here, yeah. So let's actually make it 0.05, right? Can I make the window resizable? That's a good question. I kind of want to make it resizable so that I can just resize and see how it changes and stuff like that. So there is an init window, right? Let me see if I can do anything about that. Init window. Resize. Is window resized? Set window. I suppose we can set window state, right? Platform. Set window configuration state using flags. Okay, so it doesn't. What kind of flags do I have? Set. I can set window size. Resize. Is window resized? Okay, so I think I need to Google that up. Raylib resizable window. Resizable windows. So people discuss that on Reddit. I found flag resizable window mentioned over here. Okay, good. So 2016. Just edit new flags. Thank you, Ray75. I really appreciate that. Set, I suppose, set Windows state. Can I get Windows state? Because I don't know. What if I... What if I set the flags and I reset some other things? Okay, I should just go ahead and try that. Right, set Windows state. And what was the flag? Resizable. And the resizable. Yeah, there are literally flags. So I'm not sure how good of an idea that is, but we'll see. No, I can't resize this. I still can't resize it. It didn't change. I don't know how to make it resizable. Web slow. It is what it is. Do I have to do that before I created the window? So that's a very interesting question. Maybe that's what I have to do. Because the code in the source code kind of implies. Nah. Set window resizable. Doesn't work. I don't know why, and I'm not sure if I care. I basically implemented everything I wanted to implement. Right. Almost. So it would be kind of nice to maybe use 0 as the minimum, you know what I mean? So I'm gonna just overwrite minimum to 0 and let's see how it goes. Right, I think. Yeah, I think because that's better. I'm just a little bit afraid. So how are we gonna handle the situations when it goes below the 0? It's actually super easy. If min less than 0, actually, if it's greater than 0, it becomes 0. That's it. So essentially, if it ever goes below, we're gonna leave it as it is. But if it's higher, we're gonna still snap it to 0. So that's basically what it is. That's basically what it is. Set config flags. Okay, I'll take a look at set config flags. Right. So that's much better. So you can see how this entire thing sort of like getting smaller and smaller. It would be also kind of cool to have the initial limit for x, if you know what I mean. Right. So we can do something similar for x. So this is minimum for x, and we divide this entire thing by count. But essentially we have this sort of n, right, if you know what I mean. Right, n. And we can say, alright, so if n less than 100, that means it's going to be 100. Right, if it's bigger, we're going to let it be bigger. Right, so that way, we're going to have a very interesting effect in here. Yeah. Isn't that cool? We can even make it, I don't know, 1000. That's even cooler, I think. Please tell me that it's cool. Look at that. Yeah. So, yeah, I'm gonna get this has to be 1000 in here. So we can see how the neural network is learning. So this is its cost function. We also can add some sort of a grid. We can also add some sort of a grid so we can see how all of that. So there's a lot of things you can improve in here. You can keep improving and improving. And yeah. So this is something that I noticed with a lot of models when I was like experimenting with this kind of stuff, that they jump very quickly at the beginning, and then once they sort of figure it out their configuration, they're doing like a very small optimizations to this configuration. You know what I mean? It's kind of an interesting effect that if you never done that, you would ever expect. So it sort of like goes through these energy levels, right? And then it finds the configuration, and then it smooths out and something like that. That's something interesting, right? Like, why is it doing that? Like, why? Like, what makes it do this kind of jumps? This is very interesting, right? Isn't it? So, okay. And it just keeps improving and stuff like that. It's really cool that we can also see that. So let me see. So somebody suggested that we need set config flags. So let me take a look at what that is. Set config flags. All right. Set initial configuration for C view flags. Okay. I suppose. Do I just have to set that thing there? Init window. Right. Is that what I have to do? I'm gonna just assume, I don't know. Like I probably need to read the documentation. Okay, that's cool. All right. So now, how can I get the size of the window? Get window size. So I can get window position, but I can't get window size. The jumps are maybe related to the learning step. Yeah, maybe. We can actually make half of the learning step. Right, so and see if it's going to make any difference. So this is a half of the learning step. The jumps are smoother anyway, but they still exist. You know what I mean? So I made like a half of the step, the original step, but they still exist. Oh, you have to get the width and height of the windows separately. Jesus Christ. The consistency of this API is a top notch. But by the way, I'm not dissing this library, by the way, right? So I think this library is very cool. Let me get it out of the way. This library is pretty cool. So it's just like me being grumpy when I'm working, right? So when I'm working and doing an actual shit that actually works, it gets my brain in a very specific state where I'm very critical about literally everything, right? So that's why it may feel, because people see me only in that mode, right? So people see me only in that mode and they assume that I'm very grumpy, very angry person. In reality, I'm not actually. Right, so it's just like when I'm working and actually need to get something working, I get in this very like state where I'm critical of everything, and it may look like I'm very grumpy and angry, but it's just like it's a part of my process, right? It's a part of my process. Okay. So let me see. Get window width. Get screen width. But does it give me get current? I suppose it render width, right? Get window. I suppose it has to be get render width. It must be get render width. Okay, so we're gonna assume that it's get render width. Get render width. I will assume that this function caches all of these values, so I can call it as many times as I want, because I'm too lazy to cache it myself. Okay. So yeah, that's cool. So as you can see, it adapts now to this entire thing. Very adaptive thinking. So the apoging, right? We can even make a cost plot, maybe a ring, right? How is it called? Ring buffer. So it basically removes the old things, but it's actually very important. You kind of want to see the whole path anyway. I didn't think removing that stuff is a good idea, actually. Yeah, I don't think so. So it's better to actually see like literally everything. It's way better to see everything, literally everything. So that's pretty cool. So we can now also try to test other neural network, which is ZOR, and it's way simpler, but it will be able to show us still some process. Yep. So is it gonna do another jump? I'm pretty sure it's gonna do another jump at some point. It's going for a jump. It's going for a jump. It's gonna make it. I'm pretty sure. No, it's not making it. It doesn't really. It's kind of doing a jump. Okay, cool. So, and as far as I know, by the way, you also have a text, don't you? So we can render some shit, like some additional information about what the fuck is going on. So we can replace I with epoch. Epoch. And then epoch. And just like print the actual epoch. Epoch. Is that how you pronounce that word? I'm not really sure, but anyway. Let me do something like maybe, yeah, it's kind of annoying. So I'm gonna put it like this. H width height. There we go. So that's what we have. And in here, we can do something like Raylib draw text. It's image draw text, just draw text. Yeah, boy. It requires like the actual string. So I suppose epoch. Oh, okay. I put an accent on O because this is how we put accent in Russian language. So in Russian language it's called epocha. So we put accent on O. And that's like just what my brain used to do. So I really apologize. Okay, so let's actually have some sort of a buffer. So this is going to be something like this. And we can do sm printf. Epoch. Same in German. Okay, so we're gonna put, I suppose, ZU in here, and so epoch. All right. So we probably have to specify the buffer, right? So we specify the buffer and the size of the buffer. All right. So buffer. So where we're gonna put that? I suppose in terms of x, it's gonna be 0, and in terms of y, let's also make it a 0. So in terms of font, it's going to be interesting. I think it should depend on the size of the window, right? So we can say it's going to be maybe something like this, right? So in terms of the color, let's make it white. Right? So and let's see how it's going to go. So the fact that we can draw text is actually, that's a very huge ass epoch. So let's make it smaller, maybe even this small. Yeah, that's better. That's actually very cool. It's really funny how it's just like... So we can see some shit in here. Another thing I would like to do is probably some sort of a grid, if you know what I mean. Right, some sort of a grid would have been actually super useful. Yeah, but I'm already streaming for almost 4 hours, but... So all of the necessary information is available in here. We can even do something like out of the max. Right, max epoch size to max, and we're gonna put it in here. Right, then we can just do yeah, so as you can see, it even says like how many are we gonna do and how quick is it moving. So it's limited by the FPS, as we already discussed. It's limited by the FPS. To make it not limited by the FPS, I would like to actually run the learning process in the separate thread. So that will require, you know, doing pthreads and stuff like that, but overall, that's kind of cool. We can provide more information in here. In fact, we can say rate, right? And here we can put the rate. Maybe rate and the maximum amount of epochs could be configured somehow. You can run multiple learning iterations per frame. Yep, true. Maybe that would be faster. So, for example, I don't know, less than like 10, right? And it would be also kind of nice to maybe do something like this. So let's actually run 10. Yeah, that's a good idea. So 10 learning iteration. That's actually way faster. What the fuck? Yeah, that's a good idea. Thank you. And we're done learning. So that's pretty cool. That was way faster. So let's try the adder now. Okay. Yeah, that learns even faster. When it iterates faster, I think it's more spectacular in terms of like if you look at the right. I think it's more spectacular. It would be kind of cool to also handle like R and restart this entire thing without like recompilation, but I mean I can just restart the application like so. That's so cool. Holy shit. Right. That's so awesome, I love that. This is actually a very cool tool. Right, this gym thingy. It's actually really cool. Yo. That is awesome. What the fuck? The fuck? Yeah. Alright, so now we have a gym. So I'm gonna clean it up off screen a little bit, right? And then I'm gonna like post the cleaned version on the source code on GitHub, so you'll be able to read all that. So yeah, that's pretty cool. So it would be kind of cool to actually do everything from that single application and then just dump the neural network, and then you would use nn.h to sort of deploy and integrate the neural network that you trained into your application, right? So, but yeah, that's the result of today's stream. Like, this is literally what we do within like today's stream. Right. Thank you so much, the creator of the Raylib, for such a beautiful library. I think their nickname is Ray05. Thank you so much. It's actually very cool. I kind of like this library better than SDL, honestly. I think it's better than SDL. Like, it was super easy to build completely from scratch, by the way. Alright, so just like install it and use it, and it does way more than SDL. As far as I know, it even allows you to define your own shaders, right? So, but if I remember correctly, it doesn't really abstract shaders away, so you have to be aware of the backend it's currently using to come up with the correct shaders, but maybe it does something for that, I'm not quite sure. So, yeah. Like how they highlight, it's just like, yo, so freaking cool. And then they refine. All right, so I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on next Azuzin. Love you.